The Earth is very flat.
Oh, my countdown's not working. What's going on, everybody? It's Wednesday, May 12th, 2021. Welcome to Brandon's Show. It is Free Ballin' Wednesday. We're going to have an hour and a half with no globe proponents, whatever the hell they're calling themselves now. Glurfers? I don't know. And then we'll open it back up and go from there. Who is out in the chat? Flat for Life, Sean Hawkins, Arwin. Arwin distracted me. Rob the Truth, Rachie, Page 42, Amanda Young, Carlos 888, Ian Adams, SE Montreal, Bill G, and let's see who else. Dan Morris, what's up, Dan? Scrolling, almost unbelievable, Ranty himself, Gary Wybinga, and Enigma. Bill G got first again. Bill G is killing it. Hey, Bob. What's going on, man? Okay. Let's go to Discord and see what's going on. Yo. Got Jeremy and Rob. What's up, guys?
Dylan, how you doing?
What's up, Brandon?
Good, man. Good. Busy as ever. I'll tell you that.
I just want to say right now, shouts out to Miggy. Because of him, I made a year's worth of salary in the past week. So, thank you, Miggy. Also, anyone that wants to
is an oracle.
Anyone that wants to fuck with us with crypto, might not be too late. So send me a DM. I'll put you on to the room.
What are you doing? Jeremy?
Coins on like Pancake Swap.
Shit coin harvesting.
We killed it. How many years salary did you make, Brandon? Probably 2 at least. You went in heavy on some shit, no?
I did pretty good.
Yeah.
Can't complain.
Killing it, bro. Even the people that came in light with us are up thousands of dollars. People that only started with a few $100.
Miggy picked the right coins.
Invest with you, Jeremy? Is that what you're saying?
What's up?
Invest money with you?
No, not investment. Huh? This is not financial advice, first of all, and I don't want anyone's money.
Yeah, I'm asking what are you doing? Because I guess I missed it. I don't know.
We're just taking our crypto, our Bitcoin or whatever we got, Binance coin, and we're buying these new coins that come out. Some of them are doing really fucking good. Safe Moon, Feg, Pig Coin,
Shiba.
These all
Shiba. Oh, I got busy on Shiba. No, not on Coinbase. You got to go. It's a whole process to get through them. We'll guide you through the whole thing. It's once you get it all set up, it's pretty easy.
It's a crazy process. Crazy.
Yeah, we're here for you though. Like I said, anyone that wants to fuck around, send me a DM. I'll send you an invite to the room that all our peoples are in. Right? There's mostly flat earthers. There are some globers in there though, but we keep it money.
I'll send you a DM right now because I'm trying to get into that. I already bought some Bitcoin, but want to get more into it.
Oh, this shit that we're into is like Bitcoin on steroids, bro. It's like crazy.
I only have right now, like I just started like 2 weeks ago. I only have Ethereum and Dogecoin. I made some money on Doge and Ethereum already. A little bit, but I mean it's all right.
Hey,
I want to get more involved in it.
Money is money, you know?
Yeah, I mean, send me a DM. Whoever wants in, I'll put you on straight away.
I already did, man.
I got you.
No show yesterday.
Yeah.
Let me hanging out.
Sorry. I put notices out there. I messaged you guys in Telegram and YouTube.
I don't have you in Telegram. Let me. How do I?
Oh, not Telegram. Sorry. Discord.
He uses Telegram for the 33rd Freemason Illuminati meetings.
Yeah, the special version of Telegram, though. You won't be able to download that unless you've taken the blood oath.
You
But
get your pay, huh? That's how you get your paycheck from the FBI.
FBI. Huh? I'm not a Fed. Come on, what are you talking about, man? No. See, I don't get a paycheck from the Illuminati. What happens is once you get your 33rd, they just give you access to the system where you can just pretty much put whatever you want in your bank account. So that's why, you know, you don't see a lot of
That's
people.
how it works, huh?
Yep. Yep. So it's pretty cool. Not supposed to tell anybody, but I'm sure you guys can keep it a secret.
Do you guys know
Live on YouTube or anything.
when is Ranty debating?
Yeah, you can trust us, Brandon.
What is that guy he's debating?
Witsit.
Witsit, yeah. When is that debate?
Witsit is a beast. Witsit's a beast. The debate is supposed to happen Saturday, I believe.
Between Witsit and
What
who?
channel?
Ranty.
And Ranty.
Yeah. Should be exciting. I forgot where they're doing it at. I think they're doing it on...
Randy's just going to hand wave everything.
Who is? Who's going to hand wave everything, Rob?
Ranty will hand wave everything Witsit tells him.
Fuck, I forgot where they're doing it at. I don't know. Somewhere.
I'll bet you it's on Conspiracy Cats.
No, they picked somewhere else. I forgot the name. I think Witsit's done debates on this guy's shit before. What's the name of it? Come on, guys.
Oh, it's
you know
a
what it is.
weird channel or what? Here, let me see.
No.
Is there an advert out for it already?
I don't know.
Ranty versus Witsit. Somebody
It's
battle.
for modern debate.
Oh, modern day.
Yeah, I
debate.
think that's it. Yeah.
Yeah, it's pretty reasonable. I think that's where I debated cats, right? Or is that a different one? I don't know. I can't keep track of them anymore.
I think that was different.
Oh, that was agree to disagree. Yeah.
Yeah.
Modern day debate's a bigger channel.
Yeah.
Cool. Well, that should be interesting.
It's getting pretty bad. The host used to be more chill. Now it's like more, because he's getting into podcasts and all that stuff. Now he's like, I don't know. He doesn't allow too many like jokes on the people and stuff like that. I don't know. It's getting bored.
Who is getting? You said
That channel though, the
Oh.
modern day debate. Yeah, he was more chill. Like he didn't care that much, and now he's like tightened it up. Like, he doesn't allow like to ask questions in bad way. Or, yeah.
Okay. Well, yeah. So look forward to that on Saturday, I guess. What else is going on out there? Anything good? No.
Not much. Same old shit.
Same old shit. Yeah. I hear you. I hear you there. Brian is going to be here tonight. Brian Leakey. And he is going to present his model, I think, unless he's messaged me and says he can't make it tonight. So he has come up with a model that has predictive power. What do you think about that? I mean, that's what it's all about, right? Being able to predict something you already know the answer to.
That's what they tell you.
Yeah.
Yeah, shout out Brian Leakey for the effort. Let's see it. Good
Yeah,
stuff.
Brian's balling.
Yeah, he's full
Hey,
on,
Brad,
isn't
how
he?
y'all doing? Can I get a mic check?
Hey, Brian, how you doing?
You're good. You're good.
Thank you, man.
A little low, but you're good.
Let me ask you, is this better?
Yeah, that's better.
Way better. Yeah.
Brian, the man of the
I need like
hour.
about 15,
The man
I
with
need
the
about
plan.
15 minutes. I need about like 15 minutes or so, maybe 15 to
You
20 minutes.
you got
but,
10 minutes. You got 10
All
minutes.
right. Yeah, let me hurry. But yeah, I got like just, I don't know, a little 8-minute presentation, however long we want to talk about it. And it's a model. It's mathematical to make predictions, just to stop the dumbass questions, like like the questions like why can't we see, the dumb professor questions. You know what I mean? Why can't we see UK from New York, and how does the sun set, and the angles, the flare, all this shit. So we'll put together a little something, and it's a work in progress, but it's pretty worked out. So I was gonna do that in about 15-20 minutes if everybody's up for it.
Nice. That's awesome.
Yeah, looking forward to that, man. You're the man of the hour, and it's globe free tonight, so you won't have any interruptions from that side, at least.
That is awesome. All right, let me do what I got to do real quick, and I will be right back.
You got 10 minutes. I'm timing you.
Sorry, I got distracted there for a minute with chat. Okay, well, while we're waiting for Brian, who's got something to talk about? My brain is kind of out to lunch right now.
I've been out of the community here for like about the last month. I've been doing other stuff. Is anything new other than ranty, going crazy? Is that anything going on?
Well, I think not much that I can think of, to be honest with you. Anybody think of anything that's new?
I can think of something.
Yeah, go for it.
Well, I remember when Ali interviewed Ranty, he never got to talk about it. It was something very, very interesting about the gyroscopes. I wonder if Ali feels like talking about it.
Cheers, Jesse.
Hold on, we got to clear something up. Is it Ollie or Allie?
Ali or Ali, whatever anybody wants to call. I've been called moron, and we all have.
Never mind. Ali B, the man. That's what you call him.
I'm easy. I know. I'm easy going. I was just about that experiment that they did at, and Ranty was he was talking about an experiment someone with FE Core did, and you were talking about the other day. I think.
Oh yeah, I know what you're talking about. Yeah. Yep.
Right. Well, I was just talking about how the guy says it processed one way, and then he'd spun it in a different direction and processed another way, the opposite way, and he turned it upside down. And so the point is that that the force, if we are spinning, there's a force acting upon in a linear direction, right? On that, and wherever that force is pushing upon the gyroscope or whatever, it'll go perpendicular to the direction. So if you push forward and the gyroscope's rotating away from you, it'll go to the left. If you're on the other side and it's rotating towards you and you press, it'll go the other way. So that means if you spin it different. And well, that actually proved that there was no otherwise it should have just went the same way, but the fact that it went different ways, as I say, but it's a big subject with gyroscopes. That was the thing that convinced me with a gyroscope in the aeroplane, that and water. They're the two ones. So I'm pretty convinced, because the gyroscope that's in our attitude indicator, it's specifically built because of its properties, and it's fitted in there because of its properties, that if there's any deviation of where it's set at, the perpendicular to horizontal or whatever, it'll maintain that. And if there's any deviation from that, it'll register it on the attitude indicator. So it actually maintains the same direction, the same vertical axis that it did have when it took off. And if it travels 3,000 miles, you're talking, it'll be 5 degrees off, or they would be going round a curve. It's that kind of proves they don't go over a curve, basically. And
Oh,
I've heard
yeah.
Bob and Big Blue about pendulous veins and all that, and they didn't have a clue. They don't even, they just lie. When you get to that point there, that's why I don't like they two guys, is because they lie when they get to there. They don't even know the processes because of the electromagnetic fields in the instrument panel, because it's electrical, and all electrical, we all know that electrical, doesn't matter what it is, it will give off a electromagnetic wave or whatever. It'll have like will give that off, and gyroscopes will get affected by that, and that's why the pendulous veins there are there. It's to connect it back to its original, you see. So when it goes off, the pendulous veins correct it back to the position it was when you took off, which is vertical, and it would be impossible. And they explain all sorts of shit and stuff like that. They just basically lie through their teeth when they talk about it. But that experiment, people should watch that experiment with the guy from the FE Core and listen to what he says. And then the last experiment he does, he only spins it one way, kind of thing. It's just getting a grip of what a gyroscope does when you put a force in it, dependent where you put the forces.
Well, the thing is, we got a gyroscope, right? We know for a fact that movement will cause the gyro to deviate. Now, you set it on a table and it deviates. Could be something more than the motion making it deviate. We know that temperature affects the deviation of the gyro. There's a lot of things that Globers don't like to take all their variables into account: magnetic fields, electric fields. So
the friction is the biggest one, Jeremy. Friction causes it. When it slows down, when a gyroscope slows down, it starts to process. Start from there, right? So if you get it up to speed, if you can keep it at that speed, it won't ever process, unless you surround it by wiring and stuff like that. And then there's a higher probability of it happening. But otherwise, it won't process. It will stay rigid in its space, because if you keep it spinning at that constant speed, it won't move. It won't process unless it's due to friction. That'll be the main thing that it moves because of that, because that affects it.
Yeah, there's a minimum RPM. It's like you can get a good up to 10, 12,000 RPM.
Yeah.
It will not process. It will maintain rigidity unless a force is acted on it. Like if you touch it, you have what's called the right hand rule. So if you push it, it processes.
It's kind of the same.
There has to be a force applied to it.
Yeah, exactly. And it can't be gravity, right? Gravity. This is a great thing. That's why I get Rumpus, and I got Bob to admit that gravity affects a gyroscope, and I've got Rumpus to admit that, or say that gyroscopes aren't affected by gravity. So they can take that out of the equation, how it's sort of, because gravity is a force apparently that goes to the center, that makes it point to the center of this amazing spinning ball, or whatever they call it, right? But if it doesn't affect it, well, because you would have to imagine, right, if it didn't affect it, that gyroscope would, and the pendulous veins, that whole unit, as with the aeroplane going over the curve, would have to turn in motion with it, if you know what I mean. So it'd be rigid, but even though you were angling the plane around the corner, whatever, the gyroscope would lose its rigidity. Well, according to these people that say that it goes around the curve, it would lose all its properties of rigidity in space, which would make it pretty pointless having the thing in there. To me anyway, because it's specifically designed to show when, specifically designed to make sure that a plane is flying horizontal or 3 degrees nose up or whatever, and it's ridiculous. These guys come in and they talk, they just lie through it, and that's like the biggest, I mean, that's an amazing proof to prove that airplanes are flying over a flat plane, and they say they lower the revs, they lower the airspeed to bring it down, rather than point the nose down and bring it down. Well, think about that. If they're around a curve, right, they've not been flying around the curve, and they use that, Imagine the angle that aeroplane will be compared to the land below it, because remember, it's come round this huge ball. So the ground's not the same as where it took off. So it's like at 3 degrees, and you keep your hand there and put it around the other side of the ball, and it'll basically have to land tail up. It'll be tail up to somebody watching. They'll be watching this thing come round the corner sideways.
They're delusional, bro. I heard them say that. I forget who it was. Was it Blue or Dr. Bob? That once they put on the autopilot, they maintain their elevation and they can fly straight, and gravity will make them go around the ball. They don't have to touch the plane at all. Just gravity will do it. It's like they're
that
delusional.
gyroscope, though, just as you but they're not delusional. They're lying, right? Remember, you've got to remember, these guys are so-called engineers. George as well, he's an engineer, and they are totally lying when it comes to when they start talking about the attitude indicator, the gyroscope, and the attitude indicator, man. You know, they start lying, and that's why I know they're disingenuous or whatever. You know.
Yep, and another fantasy they have is they take the gyroscope and they extend it to the gyro compass, and now it's not gravity, what you were saying, one of their fantasies. Now they say the Coriolis vision, which is visual, sometimes affects, not sometimes, always affects the gyro compass. Now I put it to you guys, how does something visual affect anything, even a butterfly? How is that possible?
Well, it's like that. There's a what do you call it? There's a National Geographic video that it's specifically about Coriolis. It's only 8 minutes long, and from the first thing the guy says, just remember the Coriolis is an optical illusion, right? And now he says that 3 times during it, explaining, even though it looks like it's bending from the what they try to do is they try to trick you into that you're inside the experiment, because if you're on that roundabout throwing the ball, you're inside, you can't define anything. But if you stand outside the experiment by standing off that wee roundabout or the merry-go-round or whatever you call it, and you watch what happens, you'll see the ball going straight. So in reality, the ball's going straight. Now, take their example, they're on the spinning ball, which is another discussion where the that little merry-go-round doesn't explain it. Is totally different. But now imagine you're on the spinning ball and you're off the spinning ball watching a guy shoot a bullet, right, from your reference frame, which is reality, because you're not on that ball. You can see what's really going on. The bullet's going straight. The sniper, he might see it bend, whatever he does, but it's an optical illusion. It's not real. It's not real. And they add that conservation of momentum, preservation or conservation of momentum. But to preserve for the conservation of momentum, you've got to have a force acting on it all the time, or there's no force acting upon it to stop it. You know what I mean? So it's like, yeah, there's a load of bull. They just
not only that.
These subjects. Sorry, Essie, on you go. Sorry.
No, I was just going to say, not only that, as soon as they say conservation of momentum, they're not intelligent enough to realize that's it. That's game over for your Coriolis. I've been trying to explain that to them for I don't know how long, but it just does not sink in.
Yeah, because there's no force acting upon the bullet, right? There's only a forward vector. It comes out where you point it, unless it gets hit by the wind or whatever, or deviates with the wind. You know? You imagine that. Here's a great one. I always like, when they go on about this refraction or the sniper, well, think about that. If he's shooting over a distance, it's got refraction and all that. Imagine him, like, it's 100 meters away. Imagine the poor spotter. He's got to get out, right? It's 7/6R. It's 4 meters, the humidity, the temperature. By the time he gets all that jotted down, the target will have fucked off, man. You know what I mean? It's ridiculous.
They're delusional, bro. On one hand, they say that, oh, we can't see the Coriolis effect. You need like long distance, snipers over a mile, cannonballs. At the same time, the number one astrophysicist, Mr. Neil deGrasse Tyson, says that with a ball, right? The football. So now, which is it? I tell them, you want to prove Coriolis? Get a football, kick it, do some measurements, film it, show us, and it's game over. Besides that, close your mouths. There's no such thing as Coriolis on Earth. It's as simple as that.
You got to remember, he also did some quick calculations for that field goal in his head.
Yeah, quick like. Yeah, so he should be able to do it again, no?
Quick calculations.
That's crazy. But the thing is, people actually believe it now. That's
sad. That's sad. You got people out there thinking that the only reason they scored this points and won the Super Bowl was because the Earth moved under the football.
Yeah.
That's pathetic.
Yep.
I think people at that stature or that, not stature, but their words affect a lot of people. I think he should be brought to rights about that, because that's not true at all. And
the Globers are quick. The Globers are quick to dismiss Neil deGrasse Tyson in a heartbeat.
I know.
I should tell you something.
But now, if you go back about 4 years, or 40, easy. At the beginning, when we started talking about him, they were defending him, and then we started finding pear-shaped, and the Earth is flat. It's flat from up there, and all that. Then suddenly,
and then they buried him.
Then suddenly the speech. He's at that mainstream. He's there for entertainment and stuff like that. But beforehand, even Brian Cox, the minute we destroyed these people, they weren't credible anymore. They just walked away. We don't want them anymore. They're not credible. Well, all right. There's 1,000 of them. You can do it with Paul Steinhardt. He says that he was one of the guys that was involved in the inflation theory, inflatrons, but the inflation theory, and he debunked it. They've known since 2011 doesn't work, and the guy got a Nobel Prize for it. Alan Guth, he got a Nobel Prize, as did Paul Steinhardt as well. They got a Nobel Prize for the work, but he even admits that the Big Bang Theory is based on 4 axioms that you can't even prove. And you know what the scientific method is? If you can't replicate, an experiment or a theory, if you can't even falsify it, it's not worth the paper it's written on, man.
It's a religious origin story. Don't even think about it like it's got any merit. It is a religious origin story. It's fine if you want that to be your origin story. That's fine. Every culture's got to have one, but don't go around saying that it's 100% the truth or teaching it to our kids in school. It's a bullshit. You better tell them. You better tell them that it's a story, and that's it. That's what I say.
Exactly, and don't belittle people that disagree or decided. I'm not buying into that. That's crap to me. That doesn't. If you really look into it, it's exactly what you said, Brandon. It is. It's a belief system. It is a religion, man. It's very, very easy to prove that. To put all that together, even the way the other particles and all that, that's the way, people thousands and thousands of years ago explained, phenomena and what reality was, and, what was it made up of, and,
reality. Yes,
yeah,
brother.
Exactly. How absurd or how arrogant that these guys are. And if you go and read their life stories or stories written about them, there's this undercurrent feeling of superiority, which you see in these other physicists, astrophysicists, theoretical physicists, architects, engineers, whatever. These people that have studied or have learned a trade, whether it's in the education or whatever, they do seem to think that they are better than them. And then if you go up into the hierarchy, theoretical physics. It's all philosophy. And that everything they talk about is just philosophical musings, right? But yeah, every single one of them will belittle philosophers. They're always having digs at philosophers. They're always, belittling them, only because that a real philosopher, a true philosopher of, in search of the truth, will realise that their whatever they are saying, their investigation or their method is totally flawed, man. It's full of assumptions that, someone with a true philosopher in nature or whatever would admit. We'll never know what this is. What this is really. It's unknowable.
It's unknowable. Yeah.
And accept it. And
Well, we
try
know
to
one
think about
thing,
what's
right?
happening.
We know that we live in 3D space, right?
Yes.
We don't live in no 4D time. We don't have no bending curvature of fabrics. We live in reality, 3D space, 3 space.
Well, what
Shout out
about
3
when they
space.
try to bring us into the spherical geometry with 2D? We don't live in 2D space.
The surface of a sphere is two-dimensional.
That's
Oh,
another
the surface
crap
of-
that they throw around. Yeah.
The surface of Earth is three-dimensional.
This is true. This is true.
Everything around us, everything is 3D. We live in 3D. We live in reality.
some of us do, SC. Some of us do.
Yeah, some of us. Well, some of us will believe in 4D. They call it a tesseract. They'll take a box, put another box inside, move it around, blah blah blah, and then they'll tell you, "Look, this is space-time." No, we live in reality. Sorry, 3D, 3 space.
They're happy with their belief system. Let them be. If they've just let us be, they just leave us alone and admit that they've got a belief system. I'd be fine. I don't care what they do. Just stop fucking
Teaching our
going
kids.
around saying that you have the truth and that you guys are like the priests, the only ones who can know the truth. It's irritating.
Yeah, we tell them water is level and horizontal, and they call us crazy. I tell them,
And then-
okay, show me some curving water. Give me
And
a
then they
ball
don't-
and show me some water clinging to it. No,
And they don't-
you're crazy. We have
Exact-
logic. We have logos on our side.
And they don't even stop there. Then they censor us. Like they say, you can't even speak what your truth is. Like, how ridiculous is that? Like, why don't at least just let us have our ideas? Let's leave us alone, like you said. To each their own.
Yeah. I mean, they don't, every other group that has a belief system is kind of shielded from that kind of attacks that Flat Earth takes. Now, I'm not trying to play the victim. I'm just saying, notice the hypocrisy of this society. Notice the things that you're allowed to openly ridicule and demean, and the things that you're not. I think that's what attracts a lot of people to the Flat Earth community, to be honest with you, is they want something to demean, and society right now tells them, these people who don't believe in the globe model, it's okay to treat them like complete garbage. That's fine.
Yep.
Te
100%.
estoy oyendo.
Did
No.
any of you guys have any of you guys seen that those
Yo
videos?
también pienso lo mismo. De hecho, cuando te dije eso, me quedé pensando en eso. Dije,
Your mic's
ha
open.
de haber cambiado por
Hot
como es
mic.
ahorita.
Por favor.
Did they?
Sí.
Yeah. Did any of you guys see that? Catch those videos with the guy from CNN going on about propaganda, how they were controlling the people with this with Trump, how they were controlling the narrative with Trump, how they were going on about COVID, and their next mission is it's through fear. The guy
Yeah,
was
I
quite
saw it.
quite
Yeah.
interesting. Did you see it? Yeah.
Yeah, it was a CNN director who got caught by, and I think we even talked about it in here,
Veritas. I think it was
yeah.
one at Veritas
by Project Veritas,
That's the one.
who's extremely political, but they catch people all the time. I don't know how they fool these people into, like, someone new shows up at work, wants to take you to the bar, and then you spill your guts to them and tell them all this horrible
You
shit
get them
that you're
drunk.
doing.
People, but they don't. Well, these people are great at extracting information and making people feel comfortable. Give them a few drinks, man. It's dead easy. It's the easiest way, actually, is to do it. That's it's get someone drinking away. It's they've targeted that dude.
Yeah.
So.
Oh, I think
But then-
Veritas does fantastic work. I really do.
Well,
Good stuff.
because I looked a bit into that before, and it reminded me of it reminded me of a guy called Dr. Donald Cameron, Ewan Cameron.
Oh, you and Cameron. Oh, shit. Bad news there.
Yeah, so exactly. So I went back, and that's what I was doing today. I was just watching a few videos, just reminding me he was deep into that MK Ultra. But there's another guy that was before him, and it's funny. I think he was Scottish as well, and it was like Andrew Blake or something like that, and he was doing experiments in I think it was the 30s or the 40s on children, doing child psychology back in, I'm sure it was the 30s, the 40s. You can get his things, but the point I was making is there it's right jumping up today, and yet still people, even if you brought out all that evidence, that there's a trail of evidence that clearly shows that we are under extreme attempt at manipulating our worldview and the way that we act, and through fear and loads of stuff, man. It's like a complicated thing, but I mean, it's like crazy full on kind of thing, which is more worrying than anything. They seem to be getting their agenda or getting their way,
They let it slip in a G.I. Joe cartoon back in the 80s. Cobra Commander, he had some evil plot, and he said, we'll just put it on TV. Anything we put on TV, these people will believe.
Oh, Nixon said that, actually. It's a direct quote from Richard Nixon. The American people will fall.
done that. Oh, sorry.
So I get all my quotes from G.I. Joe.
Yeah, it's a parody. Richard Nixon said it, and they put it on the CIA headquarters. It's on the wall when you walk in there.
What's it say?
Richard Nixon.
Sorry.
Americans will believe anything they see on TV.
It says that on the wall of the CIA?
Yeah.
Actually, I think he said, I could be wrong, that Americans will not believe anything unless they see it on TV.
Yeah,
Don't
maybe
quote
that's
me on
right.
that.
Yeah, no, you might be right. Let me find the direct quote.
Isn't
There's
that
something
true?
weird
Oh my
to
god,
put
it's
on the
so
wall.
true.
Same thing, anyways. Same thing, yeah.
It's
It's a
so
weird
true.
quote to put on the wall.
Yeah, think how many years ago that was as well. They've been practicing many years now, they've got things finely tuned now. If they're doing that, when was Nixon in the 70s, right?
They've been
Yeah,
working on this
60,
shit for
70.
hundreds of years, man. You can trace it all back to a long time ago. I mean,
I would trace it
dirty
back
stuff.
to the beginning where it got big. I would trace back to the invention of the printing press, because that's when you really had information going out on a massive scale to people. Before that, information was kept highly secretive, and no one even had access to it, or sometimes they wouldn't even let, you weren't even allowed to touch a Bible.
Well, good. Glad you said that. Before the written word, they were controlled by the spoken word, by the church, basically.
Yeah, right. The priests, who were were the only ones who could read the Bible and whatnot. Yeah, they've always had systems of control, and I think they just kind of switch from one to the other, and whenever it suits them and their agenda. But
now they're getting good at it though, Brandon. That's the thing, if you look at the reaction, what's happening around us, not on the internet with these clowns, but I mean, like, in reality, you still Do you know, when I go about with this, I don't want to talk about this thing that's going on now with the that flu or whatever it's called. That just hearing people's reactions, we are coming back into life. You know, I was talking to my dad there. He was saying things like, you know, we're allowed to actually go and visit people now, but we're only allowed to go in the garden. We're not allowed to go into their houses. And I was thinking, fuck's sake, man, you know, and I have to hold myself back, you know. I'm having to hold myself back. He's 68-year-old, and you know, he knows what I'm like, you know, and I'm biting my tongue, and I'm thinking,
allowed by who? Yeah.
But yeah, exactly. But just think about that I was like, God, this is like 1984. You know, if you think about this, look what's happening to SE Montreal. Anybody, you know, my heart goes out to people, well, all over the world, but specifically up, and I can't believe it's and it's been like that for months and months about this curfew and
Canada's bad. Hard. Canada is really bad.
It's hell up there, man, when you look at it. And then, you know, you like, just speaking to my dad there, just what because he was just talking about it, and, you know, I was just not saying anything, you know, not doing my usual, just chilling, you know, just letting him talk about it normally and me not interrupting or, but it just kind of, you know, brought it home that, you know, this is crazy. You know, even, as I say, in Britain, you know, when he was saying, like, you know, we're allowed to, and they're letting us, and I'm like, Dad, I was like, fuck them. I told him the last time, I was like, that we had a good barney about, I told, fuck them, Dad, go round and visit your friends, because they're all old. I said, you know, he's telling me things about, you know, such and how he's feeling. I'm like, Dad, fuck the lot of them, fuck the rules, man, get round and visit your friends. You know, this is no good for you. It's no good for your friends. There's no reason for this. Fuck it, you're 60, 86, so if you die, you die. There you are, but...
Good to hear from you, Alex. Good to hear from you, man. I have my hands tied, but, man, I can listen to you all night, man, sometimes.
That was a rumpus backhand. That was a rumpus backhand.
I meant that. Yeah, no, it did sound like that. No, I meant that because I got to cut in. I meant that because, you know, I was seeing if y'all was ready for me to cut in, man.
Yeah, we're ready.
You're late. We had to postpone it till tomorrow, so.
Yeah, no, man. It was a miracle. Yeah, it'd be probably better every day, you know, really. But it's good enough to show, and I hope everybody gets, you know, I hope everybody's interested, man. There's it's just a basic little. I mean, it's more than I talked about last time, but it works, and it's just a foundation, man, and we could go somewhere with it. First off, I want to claim, you know, make a disclaimer. I'm not trying to claim this as proof, just because the math works. I'm not trying to say this is scientific or proof for you know, a flat Earth, but it just shows that, you know, scientific models, you know, that's what they are. You know, you model something, it doesn't necessarily make it reality. But this is good. You know, it's a far shot better than what they have, in my opinion.
Right.
Okay, so it starts off. Yeah.
You mean if you can predict something, that doesn't mean that your model is 100% true? Is that what you're trying to tell me?
Imagine that, man. Huh. Imagine that. And so it starts off with this. So they have all these factors. So they come up with their standard refraction, 7/6R. Why did they come up with that? Standard. Okay, that's because it all the time doesn't work. What they're telling us it is all the time ain't reality. So they come up with a standard reason why it doesn't work all the time, just about. But anyway, so before I present, I just want to say the main thing that got me to looking into this model, to look at and to getting it started for us is that is the selenium eclipse, man. And I hope there's a couple new people out there listening, and if anybody's on the fence or you know, has an honest ear, picture the sun above the horizon, and it's just coming up, okay, and the moon, it's setting. Okay, So they're both above the horizon. So you can't try and twist the earth because I'm on top of the ball. Okay. If you take me off the top of the ball, then you create more problems than you could deal with. Okay. So I'm on top of the ball. I'm looking at the sun one side. I'm looking at the moon on the other side. Okay. Now you tell me that the moon is okay. The sun is not really there. Okay. I'm sitting there charging my batteries with that sun that's not really there. I'm rubbing suntan oil, or whatever, let's exaggerate a little bit, but I'm getting energy volts from that sun that's not there. Okay. And then if all that ain't enough, then when the eclipse starts, the shadow comes in from the top. It's like, hold on, the shadow is coming in from the top. So that got me thinking, if I'll tell you what, it would at least qualify as remotely possible if with that explanation, if the shadow came normal, where what they claim is blocking it is shadowing it, but it's opposite. Okay. And I think that has to do with the throw of the sun's light. And I think there's nodes up there. And when the sun and the moon are farthest away from each other, which that's always the case anyway, when they're farthest away directly across from each other is when we get eclipses. They're perfectly predictable. That's another thing we can go into modeling. That's going to be my next battle. But so what I have here is basically simple. It's basically the simple equation I mentioned the other day, but it's fine-tuned and also with an added percentage. So what I have is it's for flat Earth, it's standard horizontal refraction. Okay. And hold on one second. So wait 1 second. I wanted to mention one other thing. Okay. So okay, now this is like on a normal sunny day, like during the heat of the day. Okay. And basically at night everything is pretty At night everything is pretty set in stone. But in the heat of the day, like we get we're not going to get many black swans during midday. Okay. That's when refraction is the most. That's when the sun is heating up the surface. Okay. Shout out to Sky Free. Shout out to Pebbles on the Pond. Shout out to Brandon and his fish tank. Just demonstrations. Shout out to the Plain Truth. And because this model marries in fine with the ether band. And shout out to all these. I would say shout out. I wish Ranty was here to help us with this, but he's not. And I wish he'd have waited just a couple more weeks and considered this because, a lot of this knowledge comes from him. Okay, so I'm gonna say that they have Sky Free and these people doing these demonstrations and all these people behind these cameras will say, and anybody on this channel, we pretty much we've showed that upward refraction of light is a fact. It's easy to demonstrate on a level surface. Okay, very easy with just colder air above. Okay, you let the cold air in with a warm ground, it's easy to see an inversion. Okay, I also want to state that if the light was refracting down and making it appear higher to where we're standing, then the middays would be ruled by inferior mirages. We would see stuff above because it's appearing higher, and it would be pretty much it'd be inverted basically the way they claim it. But really the refraction, the mirages are ruled by inferior mirages, things beneath the image that look a lot like reflections sometimes, but they pretty much blend in. They appear lower than the object, and they kind of blend in and tie in Siamese in with it, whatever you want to call it. But so I want one more disclaimer before I show this is basically that in my opinion, okay, there's refraction has to be there, okay, and I think science has done an adequate job in proving that whichever way the light bends, it appears opposite. Okay, Ranty's one of the only people who was supporting that claim that the light bends down and we see it down. No, I think science has done a good enough job showing that, demonstrating that whichever way the light's bending, we see it. the opposite. Okay, but what they haven't done an adequate job is demonstrating. We've showed it with lasers. Taboo Conspiracy, shout out to him. We've shown it, like I said, in the fish tank. We showed it on the level plane in the warehouse, and we've demonstrated that with just some cold air, colder than the what's below it, then we get upward refraction, and it's very, very gradual, very gradual. None of this stuff happens fast, but I think, in my opinion, the flat Earth is 100% wholly dependent on refraction, basically, especially like during the heat of the day with distant objects, terrestrial objects. It's wholly dependent because, I mean, it's a fair question. How does the sun set? Because unless, you know, we can always keep playing the card. And it's an honest answer to say we don't know what the sun is, but it's in a apparent spot of something. And I think Jeremy has pointed that out with, you know, trying to do the sun speed. Because whatever it is, however high it is, it's still something there moving according to where we see it and where we're at. Okay, so that's fair. Okay, so they come up with the 7/6R. Okay, and
You there?
sorry about that. Can y'all hear me?
Yeah.
We hear you.
Hurry up,
So
Brian.
I'm getting
Hurry
to
up.
it. So it's basically what I
Hey.
said the other day was 5 inches. Was 5 inches per mile squared of upward light refraction, very, very gradual. Okay. And
So you're
after
telling me
looking over it- go ahead.
my bad. You're telling me the light
Well-
is going to bend towards the colder air.
It's right. And I don't think the pressure has diddly shit to do with it like they think it does. I don't think temperature has much to do with it. I don't think pressure. It's the density of the air. But here's the thing: when you're looking out 0.01 degrees and 3 miles, you're looking level with the horizon. So it's a function of perspective. And that's not my whole entire argument, but it is actually a function. So when you're looking basically level with the actual ground, inconceivable amount, that air is, and the further you get, that air is getting colder because everything starts converging down. So clouds that are a few miles high in 10 miles are above the tree line. They're right in front of your face. It's colder air. And the pressure is the same. So it's a perspective function. But so what I had to refine that a little bit and go with upward light refraction, standard horizontal refraction of 6 inches per mile squared, and it starts with a percentage. So basically, the ether band is like the bottom 4 degrees. Okay, so so 1, 2, 3, 4 degrees is 100% of 6 inches per mile squared. Okay, and then it's a parabola. Okay, let me see if I can show y'all this. It's a parabola. I charted. I didn't have graph paper, but I did a simple little chart. I got this is all handwritten. It's nothing professional. It's not professional yet, but I hope that it's spoken and I plant some seeds in everybody's heads, and we can. And one more thing before I show you all this. Okay, this answers the stupid questions like, you want math? Okay, here's math. This will predict what you're going to see. This will predict where Polaris is at every time, without fail. This will predict why the sun sets. And to me, it goes a little further, though. To me, I think we can refine the maps a little better. I was looking at the distances to Polaris or to the North Pole. And when I got to Canada, I seen in 2 degrees of 450-mile discrepancies. I seen a lot of local discrepancies. I can't expect them to just be able to map shit out as the crow flies. I don't think nothing's easy about that. So I think we could always get it better. We're never going to stop getting maps better, but I think we can use this to make a good map for us, if nothing else. But
Okay.
but to explain why we can't see UK from the coast of New Jersey, okay?
Well, they
And to
can't even get the
explain why
distance of
sunset.
they can't
Okay.
even get the distance of coastlines.
Yeah, it's a
you-
paradox.
Yeah,
Okay,
the
so this is all
coastlines are-
handwritten. Yeah. This is all handwritten, and it's going to be. So I'm stating the sun elevation, the apparent sun. Okay, not saying what it is, but what I see is about 3,640 miles high. Okay, it's a little bit closer than the sun. Oh, one more thing. I know I keep one more thing in y'all, but this unfortunately, I got some I got some bad news. Is this refraction explains why we seen the star for the Eddington experiment with Einstein, of why we seen the star poking out of the corner.
That was their GR proof, yeah.
Of the sun. It's just a function of refraction, is all. So that's the bad news. Is we're gonna have to do something with relativity and all that, because this refraction model, it lines up exactly.
What? You were doing good until now, bro.
Yeah, no, I'm
Let's
sorry
not
about
bring
that,
La La
guys.
Land into this, bro. Come on.
Very sorry about that. And so here, let me share my screen. Says video isn't available.
I've told them the
Try
whole
one more
time,
thing,
like,
hold
yo,
on.
your Eddington proof for GR fucking sucks. Some terrible proof you guys got.
It's a wonderful
Video
proof.
isn't.
Oh, it's
Terrible.
Rumpus. It's ball free Wednesday right now. Half an hour. All
Oh,
Yeah,
is it?
one more minute.
Oh, shall I go then?
No, you can stay.
No,
No,
dude,
yeah,
we're
just be back. Just come back in about 10, 15 minutes, Rumpus.
You can stick around.
Okay, I'll go.
Just don't talk. You can stick around.
Okay.
I can't get my camera to work, man. Here,
Do your damage control in 15 minutes, Rumpus. Don't worry.
Yeah.
wonder why my camera won't work. Can y'all hear me?
Yes.
We hear you.
Okay,
Brandon,
let's
tell
try.
your Illuminati people to stop blocking his camera. Come on. We're at the crux of this.
Yeah, right. This is just my screen. I don't know if you can put this on full screen. But this is just the screen that I have. Okay, yeah, I was able to enlarge it. So it's just a parabola. It needs a tiny bit of refining here, but it straightens out at the top. I didn't have graph paper yet, and I was too anxious to show you all this. But it's just a parabola, just what you would expect. And there's no, okay, so what we have here, okay, is it's just 6 per mile squared, standard horizontal refraction. The sun's elevation is 3,640. The moon elevation is 3,550. Polaris elevation, 3,655. Okay, so everything, the bottom 4 degrees is 100% of them 6 inches. You can do the math long ways, but it works out the same if you just do the percentages to the 6 inches. So you see how it goes 100%, 99, 98, 97, 96, 95. You see what I got going here? It goes down to 15% right here. And then 16 is 89, 88, 87, 86, 85, 84, 83. So each degree, you're pretty much, each degree higher in the sky is a percentage lost until we get to 90 degrees. At 90, well, basically it stops at about 75 degrees. We don't need refraction. I think all the local observations we make, we can compare with each other, and they work just fine.
Brian.
Yeah.
I apologize. I didn't realize you were sharing your camera for a minute and the audience didn't see when you started explaining on the piece of paper. Would you mind just starting at the beginning of when you were showing the paper? Sorry about that.
No problem. Okay. So you have, so it's basically 6 inches per mile squared with but there's a degree of angle function here to where the bottom 4 degrees in the ether band basically is 100%. Okay. So you could do the math the long way, but it works out the same as just doing the percentage to the 6 inches. So it's 100% of the 6 inches up to 4 degrees. Okay. And then it drops down. Okay. Y'all see at 5 degrees. Okay. This is for Polaris right now. Okay. So at 5 degrees, it's 99% of the 6 inches of refraction. At 6 degrees, it's 98%. At 7 degrees, it's 97. At 8 degrees, it's 96. Y'all see? Okay. So when you get to 75%, it's 0. Okay. It's 0 degrees because, like I said, we can compare the sky locally with each other, you know, and I think everything works out just fine. And 90 degrees, they're not declaring refraction anyway. I think that lines up with science. But let me go back and show you the sun elevation I come up with that works out for everything is 3,640. The moon elevation's 3,550. Polaris is 3,655 miles. So here the distance from the equator to the North Pole is about the same. It's 6,200. It works out just fine. But okay, so you see how everything works out. It's 100%. The only function besides the 6 inches upward refraction is the percentage that you need. So it works out perfect. So I just set up a few of them. Now y'all can jot this down. I didn't write every percentage, but if you see here, 10 degrees, you have 94%. Okay, that equals 5.64. So 94% of 6 inches basically is 5.64, right? And then it works down. I did another one. I wasn't about to do a million of them, but then I did one at 15%, 89%. Okay, is 89% of 6 inches is 5.34. Okay, and then I did like 20%, 5.1, 25%, 30%. And I cross-reference all these with the trigonometry. So we start with 15 degrees. Okay, we're going to use this as a latitude. So it's going to be the opposite of 15 degrees toward close to the equator, but it's going to be 15 degrees from North Pole, but 15 degrees from the equator. Okay, so 15 degrees is like I said, it's to 75. Okay, that's zero. That's zero refraction on this one. Okay, so what we get is we do 5,280. Wait, let's see. No. 15 degrees is 5,000. That's from the equator. So 5,280 times itself. No, I'm sorry. Last try. Okay, 2,064 miles. Okay, from 15 degrees latitude to the North Pole. Okay, so 2,064 times 2,064. Okay, times let me see what I got going here. Times 0.9. Okay, where is it? Right there, 0.9. 15%. Okay, is 0.9. So in other words, when you get so this is about to get clear, y'all. So bear with me. So 2,064 times 2,064. Okay, times 0.9 is, and then divided by 12 to put it in feet, then divided by 5,280 to put it in miles. Okay, and then we subtract the answer from the height of Polaris. So what we get is 60.5. So 3,655 minus 60.5 is 3,594, gives us 60.1 degrees. So if you're at 15 degrees latitude on Earth, past the equator, you're gonna see Polaris just barely over 60, right at 60 degrees. Okay. Now let's see. What did I do? I did 45 degrees. Okay, 45 degrees.
Is that correct, Brian? Is that correct?
Yeah. You could double check these. I only wrote down a few, but yeah, it's correct, man. I went to the calculator. I didn't do the sign and all that. I mean, I could if anybody doubts.
That's okay. So you're at 15 degrees north, right?
Yeah. Okay. Let's see. So okay, no, yeah. I want to say. Hold on. So I got this backwards, man. Is what I did. I did it backwards. Okay, so wait, 15 degrees. Yes, 15. Hold on. I used the wrong thing, okay? What I was supposed to do, thank you for catching that. It's supposed to be, okay. So it's supposed to be, here you have this. Wait a second. Wait 1 second. Okay, so 75. Okay, so what you have here is, so 15 degrees, okay, would be a 16. Hold on, let me see something real quick, man. I got that one backwards, and I'll straighten that up in just a second.
Sure.
But let me go with and then I'll freestyle a couple of them. But let me just go to 45 because it's the easiest one.
So disregard that first.
It's not
one.
easy.
Disregard that first.
Yeah, no,
one,
I'm gonna straighten it out, man. I cross-reference my information. I should have just left the damn degrees alone instead of trying to put it to latitudes. But I'll straighten that out in just 1 second. Okay, so 45 degrees is is 60%. Okay, so 60% of 6 is 3.6, right? So we take the 31. That's what it is. I got it. I'm about to go back to. But let me, since I'm already here. Golly, I'm forget. So 3,100. So 45 degrees is halfway to the North Pole, correct? So our 6,200, okay, from the equator to the pole, half of that's 3,100 miles. Okay. Anybody who lives around 45 degrees is gonna see that it's about 3,001 around, between 3,000 and 3,200. Okay, I just did it exact. So 3,100 times 3,100 times 3.6, which is our percentage function, divided by 12 to put it in feet, divided by 5,280 to put it in miles, equals 546. Okay, so then we take the height. So that's the refraction. It's 546 miles. Okay, so we take the 3,655 right here, and we subtract 546. We get 3,109. Okay, and that's just barely over. It's like 45.01 degrees. I mean, obviously, because 3,100 is the distance, right? So that's 45 degrees. Okay, now here's where I messed up, and thank you for catching me, dude. Okay, so what we have here is the 2,064. Okay, is 15 degrees. Is it's so if you divide 90, okay, I mean if you divide the 75 or the 60 degrees by 90, hold on, let me see. I wish I brought my pen, but anyway, I think it's hold on, it's 1.666, I believe.
Holy shit!
Hold on
Jeez,
now, don't do that to me.
Sorry.
It's okay. So 1.666 of the 6,200. Does anybody got a count?
Yeah, I got a calculator handy. 1.666 times 6,200.
Yeah.
Times or divide the 6,200 by 1.6.
I mean, no. Divide. I want to do this. Divide. First, do this. Divide. Divide 75 and by 90. Okay, so we're put 75 divided by 90.
75 divided by 90 is
0.83 or
0.83. Got that one, Brian? Oh, we lost him.
second. Can y'all hear me again?
Yeah, now we can hear you.
Okay, so 0.83 times 6,200. Okay, which was our distance, right?
Times 6,200. 5,166.66.
Okay, 5,000. Okay, so that's this one right here.
Ron, do
Okay,
you have a formula? for
okay, no,
this?
let's just do it. Let's just freestyle this one. Let's freestyle this one. So that's 75 degrees, right? Okay. Now, right here at 75 degrees, we have a zero refraction. That's right where zero starts. Okay.
Okay.
So what was it again? What was it again, Brandon?
Let me bring it up again. It was
4,166.66.
Oh, we're getting that echo, Brian.
Okay, hold up, man. This is like typical. But hold on, let me get back on track. I should have. Hold on. It won't even let me push button.
Do you have a
It's not
formula
even-
for this, Brian?
Can y'all even hear me? My phone is.
We
dead.
hear
we can hear you.
Hold on, bro.
Yep, we can hear you, Brian.
Okay, good. At least you can see it now. Can you?
Now you're frozen, I think. Well, just take a minute and get it worked out, Brian. Your connection issues or whatever, and then we'll pick back up. You there?
Yeah.
Okay, now we can hear you. No echo either. You there?
Yeah, I'm here, man, and I'm sorry about this. This is real time here, and it would have been easier to make a video, but watch, I'm gonna show you. This is all perfect. I should have wrote them all down and been prepared for this, but it's so much fucking just figuring this shit. But hold on. So
Okay.
here I am. Okay.
Okay.
We'll do this real time here. Okay. So 75. Okay, would be.
Are you sharing your
75
camera anymore or no?
So it's 5,280, right?
Let me bring it up again.
It says video isn't.
5,166.
Okay. Well, no, add another 3, man. I think you cut it off. Do 6,200 times 0.8. Hold on, let me do the math myself, man. But thank you for backing me up right there. But let me see.
75 divided by 90, right?
Yeah.
And then 6,200 times that one, right? And I'll add another 3.
Yeah, what is
it?
Got a couple of them,
5,166.
Okay, that's not quite what I got, but that still should work. Okay, so 5,000. 5,100. Okay, time. Okay, so do this. Okay, so multiply that times itself.
Multiply that times itself. Okay.
Okay, and 75. Okay,
Nice.
and multiply that times, and then times 5.34. It won't let me show my camera, man. I don't know why.
Times what, Brian? 5.34? What was that last number?
Yeah, 5.34.
5.34.
Okay, so yeah, so 15 degrees. We're basically doing 15 degrees latitude. Okay.
I got like
And I'm about to be rolling.
1,503,000.
Okay, divided by 12 to put it in feet.
12. Okay. Let me see what
Now
that...
divided by 5,280 to put it into miles.
And divide all that by 5,280.
5,280, right.
Okay.
What do you got?
Let me see what we got here. 23,735.
Nah, you did it wrong. You did it wrong. Hold on. Let me do it. I'll do it on screen real quick. I mean, maybe I probably didn't say it right, but let me just do this real quick. I went and got another phone, man. I should have did. Let me see. Okay. Yeah, dude, technology. Anytime I'm doing this, technology does not go my way here. Okay, here we go. All right, calculator. Okay, bam. All right, now. Okay, so let's just say, let's just do this. I'm gonna freestyle it, y'all. Okay, we're just gonna say 15 degrees. Okay, and we'll switch the latitude. Okay, but we'll just go with my function. So 15 degrees. Okay, is that's 2,064. So that would be, okay, so that's 2,064 miles. Hold on 1 second. 69 times.
Brian, maybe we're getting caught up too much on
that ain't right. That ain't right. Let me jump to 30 here, man.
Okay.
Let me jump to 30.
All right.
I wrote the wrong shit down. I can't believe I even did that. It's embarrassing. But I'm gonna redeem myself. Okay, so we'll go to 30 degrees. Okay, 30 degrees. So we'll say 30 divided by 90. Okay. Wait, it's 0.333 times 6,200. Okay, it's 2,066, right? So if you're 30 degrees, you're 2,066 miles. Okay, I'm just gonna write this down right here. 2,066. Okay, and that's where I'm at too. I'm at 30. I'm at 30 degrees, man. So that was my that no. Damn it.
Well, Brian, why don't you work it out, man?
Anyway, that computes to 60 degrees. That computes to 60 degrees, right?
Okay.
But we're just gonna do it as is. We're gonna do it as is.
All right.
Okay.
Hey,
So
Brandon,
60
I have some
degrees.
breaking news while he works it out, if you guys wish.
Breaking news? What is it?
Have you heard of Ranty? Remember when he became a baller? He flip-flopped. He said he wasn't going to diss anybody.
Yeah.
Remember that?
Yeah.
Well, and I believed him. I thought he was a man of integrity. Well, He just did a new YouTube channel called Flirspective, where the objective is to make fun of flat earthers.
Really?
That's free advertising for you, Ranty. You owe me one.
Perspective, huh?
Flirspective, yeah. So I guess that means the gloves are off, right?
Nothing's working. It makes sense because that's where the money is, making fun of people who question reality.
Yeah, that really ties into what Brandon had said earlier. There's a lot of people who get into this because it's considered a socially acceptable group to mock and to make fun of. Because there's
You guys should hear the video. He makes fun of everybody.
Do you have a link to it?
Oh, we're the only group of people left on Earth that you can legally, it's socially acceptable to just, make fun of us. You couldn't do that to a mentally handicapped person or, someone that's a transgender. Like,
Brian, can you go on
Brian,
mute for a minute while you're working that out? We're getting that.
Yeah, I pretty much got it. And dude, I just rejoined. It won't let me. This is the 4th time it's dropped me, dude. I can't say shit. It's driving me nuts, man. But dude, I got 100 of these of spreadsheets, getting it just right. And the only problem is it keeps cutting me out, and also it keeps okay. So let me just do this real time, real quick. Okay.
Okay.
Let me do this real time. Okay. So 30. Okay. St. Augustine, Florida. Okay. Jacksonville, Florida is about 4,000. I'm at 30 degrees. Okay. So 41.52. That's the distance to the pole, okay? It tells me it's pretty close to that, okay? So times, okay, 41.52 times 41.52, okay? Times, okay, now instead of times 6, we got to look up the refracted amount. So that comes out to, are you serious? Can y'all hear me?
Yep, we got you.
we hear you.
Dude, it keeps closing me. But okay, if y'all can see me and hear me, I'll just ignore this Discord isn't responding thing across the screen.
Yep, we got you.
Okay, so times 4.5, 30 degrees is times 4.5. Let's see. It's right in my way of even seeing.
All right, so you took the number of miles from your location to the pole, squared it.
Like somebody, they're playing a joke on me, man. They're making.
Brian, give us the form. Brian, give us.
Yeah, I'm giving you the formula right here. All right, I'll give you the formula after I do this one. Okay, it just keeps cutting out. It's making a hard time worse, dude. It's fucking it's cheesy. Whoever the fuck is just keeps cutting me off for no reason. Okay, 4.5. Okay, that's 30 degrees, right? Okay, that equals 75%. You see, we worked our way up to 100, right? So it's 4.5. So 4 times 4.5. Okay, divided by 12 to put it into feet. Divided by 12, and then divided by 5,280 to put it into miles. We have 1,224. Okay, so now we're going to subtract the 1,224 from the height of Polaris, because that's the refracted amount. So 3,655 minus 1,224. Okay, is 2,431. That's your new refracted height to Polaris. Okay, so now we go to the you could go to the calculator, and what you'll get is you will get. Let me see. So you'll get 60 degrees, man. You'll get 60 degrees right on the dot. Okay, here's the formula. Okay, so 45. This is where I was back on track and it cut me off. So whoever's doing that, or if it's whatever, just please don't do that. Okay, so 45 degrees. Okay, everything's right in the screen. So this is the formula. Okay, so that's halfway to the pole. So that's 3,100. Okay, so anybody could do this with me. Okay, 3,100 times 3,100. Okay, times. Okay, is 75% of 6 is 4.5, right? So times 4.5. 4.5. Okay, divided by 12. once again, divided by 12 to get it in feet, and then divided by 5,280 to get it in miles. Okay, equals 682. Okay, we can do the 0.5 if y'all want. So 682. So we subtract 682. That's the refracted drop from the 3655. So 3655 minus 600 and what I say, 82?
Yeah.
82 equals 2,973.
Pretty close.
So yeah, it is close, but yeah, I think it was no, it was 632. I'm sorry, 632. Yeah, it's real close. Okay, and so just last one is 60 degrees puts me is where I messed up earlier is I didn't count the distance. Okay, it's closed app on me again. That's the 5th time. So it's 60%. If y'all can hear me, here it is. So it's what it is if anybody's interested, I'm gonna make a video, man, because it's fucking embarrassing, dude. But I did a lot of work for this, and I keep cutting out, dude. I keep cutting out, man. I got put on the spot, then I started cutting out, dude. It just started making it worse. I got a big window in front of my screen that says Discord isn't responding. That's all I've had the whole time I've been trying to fucking do this, dude. Is an app, okay? And I don't know if y'all can see. I don't know if y'all can see the.
My Discord's been doing the same thing, Brian.
Yeah, mine's never done this ever, fucking ever. I swear to God on my life, it's done it once.
I got you. I got you good as gold, Brian. I got you fine.
Yeah. All right. So anyway, so there's how it plots on a graph, okay? And you can do this. Okay? If anybody's interested, get either watch my video later. I hope everybody does to give me that benefit. But or get a picture of this snapshot. Okay, it's 6 inches per mile squared. Okay, and the first 4 degrees are 100% of 6 inches. Okay, so it's 100% refraction up to 4 degrees. 5 degrees is 99. 6 degrees is 98, and it starts working its way down. Okay, and then it's a parabola. Okay, so it starts speeding up, right? And it but pretty evenly. I need a little bit of work getting it exact, but it's pretty exact. So it goes from so 16, 17, 18, okay, down to 30 degrees, 31, down to 45 degrees. It starts going up, and then it goes 58, 56, and it works its way down to where it gets to 75 degrees. It's 0. Like I said, we don't get any heavenly refraction, really barely any, to about anything noticeable to about 62 degrees is anything really of anything of notice. But like I said, it plotted out pretty good. But I'm so embarrassed, man. I'm gonna just get it. Look at all this shit that I did, y'all. Before I give
don't
this,
worry about it,
I did like
Brian. Don't worry about it.
Just so y'all know, just so y'all know, I did like 1,000 graphs on paper. I mean, I must have did 1,000 of these fucking things to get this shit right, because I don't even have
Bro, Brian.
Right now, man. But
Brian,
it all works out within like 0.2 of a degree, guys.
I feel like you have a wall in your house somewhere where there's like pictures and there's red yarn connecting the pictures.
A what?
He doesn't understand the reference.
You're echoing.
I didn't even hear him.
Yeah, he was basically saying that he feels that you've got bits of string connecting up bits in your room that you've been calculating.
Oh yeah. And poster boards everywhere. But no, I just look. It just closed up again. It closed up again. Every time I try to do something, see, the problem is I can't see my screen to show you any damn thing. I'm sitting here doing something, and you're not even hearing me. I think that I'm presenting something. And she tells me that I'm not even fucking.
No,
I can't even hear me. I'm presented
you,
a whole damn.
Listen.
Yeah, I know now.
Don't be embarrassed. Don't be embarrassed. Just make a short video. That way you can do it on your own time. Make sure the phone works, and we'll watch it. We'll watch it in here.
But anyway, so if you use this little graph, it could use a very little bit of fine tuning. In conclusion, here, okay, it's a parabola. It's pretty much a parabola up to from about 4%, where 100 stops, and then to 75%. Okay, and so you can plot it out on a graph, and the Polaris elevation works. The sun elevation. So think about it. So the sun on the horizon is 0 degrees refraction. So 3640, and the distance is. I mean, if you do the numbers with the sun, it sets like pretty close to where it's supposed to. It lingers for and Polaris lingers, I think, for like 1 degree past the equator. But I was going over these numbers, man, and I was looking on Google Earth, and their numbers are a little bit sporadic for distances to the North Pole on Google Earth and on other maps. I think we can use this to refine a map to call our own. But yeah, I'm gonna go make the video and show you how these numbers work out. And I'm very apologize. I appreciate y'all's patience, but I messed up, A, by getting cut off, and B, by switching the latitudes with the degrees, because I did it all in degrees, but that's opposite of what the latitudes are. In other words, 15 degrees from the North Pole is opposite the latitude. That's by the equator. So I reversed everything. I tried doing it on the fly, and I failed miserably with the shit shutting down on me. But thank you guys. I'm gonna go make my video.
Okay, thank you, Brian. That was very interesting. So it sounds like your model does have predictive power. And sorry we had so many
100%.
troubles there.
Me too, bud.
Can I have a go,
I can't
Brandon?
mute, so I'm gonna have to go. It won't even let me mute. I gotta go.
All right, Brian. Yeah, go ahead,
Let me
Liam.
fucking hang up.
Yeah, can I come from a different perspective? Oh, I've got a massive echo there.
Yeah.
Oh, there we go. It's gone. Brian's cut off. It was Brian.
Right.
Okay, good.
Can I share my screen?
Yep.
Is that all right?
Yep.
Yeah, I mean, a lot of people have seen this knocking about. But I've done these Polaris maths quite a while back for conspiracy cats, it was. And it basically claims the same as Brian, but I think, well, let's put it through the test. But I've done this little animation to show you each triangle where the observer would start here and Polaris is up here. And then as the observer goes 69 miles this way, the apparent degrees would appear to drop. Okay, so if I just run that, it will show you, if you see this coming down, it's apparently dropping until it gets to, let's say, the equator, and it becomes 0, and then I just reanimated that bit, but leaving all the triangles in. So if we can go for, I mean, I can go through the actual equations that I've put in there, but this is the distance that I get out of it using a trigonometric formula, let's say. That's to just find the hypotenuse, but that's the main formula that a lot of people have seen me tout.
What is
albeit a switch. I can show you if you bear with us a second. I don't know whether I have to. Well, wait there. Let me just test it. So if you can just shout out 3 random degrees. I mean, what was Brian's testing? 30 degrees, was it?
I think he did 15, 60, and 75.
So what mine resolves is the distance to the pole. So the distance to the zenith point of Polaris. So my 30 degrees would bring up 4142. So I don't know what you was calculating earlier. It was...
Glenn, what is apparent altitude? What is it? Why isn't it a single altitude? Does it move?
Yes. As it drops down.
Polaris moves depending on your latitude?
No, depending on how far you are away from it.
Right.
When things,
when
you... No.
No,
the star
so what
stays.
does apparent altitude mean?
Apparent altitude is the angle it's at.
We know what the angle is. We can measure that. Right? That tells us how high it is on a flat Earth.
No, but I got 4132,
You said
Gleam.
it
So
doesn't
fucking, you're right on cue, bro. Is it's right underneath the datum, right underneath the zenith. I had 4132. So yeah. So now, and I'm writing these down, and I'm like, God, man. And now watch. Now that I'm not showing this paper, all this stuff, I'll never cut out again. Maybe once a month. Maybe it shows my whole screen. Like crazy. But anyway, just try it, Gleam, if nothing else, while I'm doing this, or when you get a minute. Just doing others, because I had 4132 at 30 degrees, but
give me another one.
That equates to 60 degrees latitude, right? I mean 30 degrees latitude is that equates to the 30 degrees away from the equator. right? So that's 4,132 miles to right directly under the zenith. And then you do the math, and I want to get back to my video, but I couldn't help but tell you, man, that's the exact number I got, man. I just had it mixed up, man.
Anyway, Ruhif, do you agree that when you move away from something, if something's static up in the sky, let's say like there's a helicopter, okay, you're standing under it, it's 90 degrees above your head, yeah? We agree that. Then as you move away from it in either direction, you look back at it and it drops in your, as in its apparent altitude drops.
No, that's its actual height. The angle changes. Its height above the ground does not. I asked you a minute ago, does it move? And you said no.
No, it's
But it
apparent. That's why it's called
appears to get
apparent,
lower.
not
Yeah, that's the
actual.
angle. That's the angle.
So it's apparent. It's apparent. But that's
No,
the
the
figure that I
apparent angle.
use for my triangle.
Do we really
Yeah,
need the two
Polaris
views
doesn't
right
move,
here?
right? On either model.
Yeah, but this works. This has predictive power, which I think I was testing it, which was against McToon's maths. It was coming in at 0.02% different.
How high above the flat Earth is Polaris?
When you're
How
under the
far away
zenith
from the
point,
ball Earth is Polaris?
3,958.
Number of light years.
Obviously,
What was the
when
height?
3,958.
All right.
Obviously,
so if
when
you're
you're
at 45 degrees latitude, right? Go to
45, yeah, I've
Go to
got
45,
3107.11. What have you
Yeah,
got?
that's how far you are from the North Pole. But if
Yeah.
something's at 45 degrees, then it is the same height as the distance.
So
You said it was
apparent altitude.
3,958.
Apparent altitude is the same height as the distance. That's
Then
odd.
go to 3958. Yeah, if you're 3,000.
What are you doing here, Ruhif? Ruhif, bearing in mind, right, mate? Bearing in mind, mate, I've got you blocked on Discord for wasting my time, mate. What are you doing here? Interrupting me.
I'll go. I've got to go in a minute anyway.
No, but I mean, I don't know what point you're making. What point are you making? I've made maths that works.
We don't need
Right,
Okay.
45 degrees.
What point are you making?
45 degrees, you are 3,100 miles from the North Pole, right? That height, apparent altitude, is how high it is above the ground. But you just said it was 3958, not 3107.
No, because it's apparent. It's only actual when you're stood underneath it.
This is basic trigonometry.
Yes,
Gleam,
it
he's
is.
not capable of understanding this. Just so you know, I've tried to explain it to him 10
Because
times. He
apparent
doesn't.
altitude is fucking bullshit. Again, does this work on like a tree? Does it work on a tree or a mountain?
have
or a building?
apparent
It's
positions?
trigonometry.
Yes, it does, Ruhif.
It does.
As
So if you're
yeah.
100 feet away from something,
God's sake,
if you're 100
Do you
feet
know what
away
this is
from a
calculated?
tree and you look up and it's 45 degrees, how high is the tree? If you're 100 feet away across the ground and it's at 45 degrees, how high is the tree?
Ruhif, this is talking about
It's 100
Polaris.
feet,
If you've got, this is to do with ground
It's 100
space and
feet.
sky space, not objects. Okay, the object is Polaris. Polaris is at the 3958.
If I'm 3958 miles away,
Every
angle is it?
other one is an apparent drop to represent the actual degree drop.
Yeah, and I asked you, does this work for trees, mountains, and buildings?
It does. If I
Okay,
spend
so if
20
you're
minutes
100
doing
feet
it,
away-
but I don't think you're worth the time, Ruhif, because I don't understand your point.
Well, I'll keep going for the next minute unless Brandon blocks me, and then I've got to go. If you're 100
tell me
feet
your
away
point.
from a tree and it's at
Yes.
45-degree angle,
Yes.
what height is the tree?
Do you want me to stop the presentation and do your maths?
Sure.
Ruhif, shall I just let's go why I blocked you? Yeah?
We can.
Because of analyzing data, wasn't it, Ruhif? Analyzing data where I analyzed a particular Blackpool picture which was 4K. You analyzed a picture which was 5K. I come back to you with a pixel figure of 1 degree. You come back and told me immediately that was wrong. I must have done
Analysing
something
different
wrong.
pictures, and you had plenty of chances to tell me that.
No, it was told you that. I cited you
you
straight
didn't.
back at you.
No, you didn't.
I
You
showed
sent
you
me
the
a link.
actual calculator, and you said that calculator's shit, and it resolved to your
No,
maths when I put it in
said it's overly
5K.
complex. I said it's overly complex. I did not say it was wrong.
Overly complex.
Yeah.
It matched your maths, mate. It's just you made a mistake.
We're using
Okay.
different resolution
Okay.
pictures.
Either way, what degree doesn't work? We can
45
go
degrees.
through the mechanics.
45 degrees.
45
Go
degree doesn't
45
work.
degrees.
So the 45 degrees
Yep.
is 3107.11. What's the distance to the North Pole from 45 degrees, please?
That sounds about right. 3107.
So
But you just told me that it's 3,958 miles up, which is not 45 degrees, is it?
what are you on about?
You've just said it was 3958.
You've misunderstood again, Ruhiv. Can you
No,
slow
your
down and let me
apparent
explain?
altitude is
You've
a
interrupted my
bullshit
presentation, misunderstood the maths again, and now you
Again,
want me to wander off and do a tree?
Yes, if you're 100 feet away over the ground.
No,
from a tree,
Ruhiv, slow
it
down.
appears
Slow
at
down your
45 degrees.
ADHD mind, mate. Right, let's concentrate on what you've just got wrong first, so you understand that. Is that okay?
Wrong,
Okay, well, you've just said, well, no, wait there, Ruhiv. You just said my
No,
maths
I
was wrong,
literally have
and
to
then
go
I
and
said,
type it.
where, what degree? And you said 45,
To be
and then you said,
continued,
no, that
William,
sounds
I've got to
about
go.
right.
To be continued. See you later.
Oh. Is that unreasonable or what? To interrupt a man and then to basically...
That was ridiculous.
Yeah, basically say, no, you've got to do a tree.
Thinks that just he's not understanding that the apparent
Maybe.
position is the dropped position because it's the what it appears to be now that you've moved. It's not its actual
Amazing.
height anymore. It's the apparent position of it because you've moved. Like, how could he not get that?
No, just because it was on the next screen, sorry. Let me load up where I've got that from. You can see, I don't know whether you can see my mouse on this, can you? If you look at the angle Y here, we've got this equation right here. So I want to find out the apparent angle here, or the apparent height. That is what I've used as the apparent height. So it's based on perspective from this end rather than actuality from this end, and assuming the Earth is flat. And it is just basically a reverse engineer of exactly what the globe says. And as I say, I come within, from McToon's figures, we tested about 3 or 4, and it was within, one was like 0.02 something, the other one was like 0.011 something. And I was expecting, I said, find anyone within 5% error. And you can't even find one within 1%.
How do you calculate apparent height?
Using, oh, sorry, I just shut that right now. It was that one there. Did you see it?
Not really.
Did it stop?
Yeah, the video stopped. Yeah, there it is.
Yeah, there we go. Okay, so it's this one here. Side Y. Anyone can look this up. I'll leave this up just for a quick second. You can look this up and download it yourself and look at all the formulas. He gives it you in there, so you can put in your own figures, and it will work out both angles, both sides. But he tells you all the difference. So if you want to solve for this using this is the formula you use in Excel. And obviously, always remember to wrap your degrees or radians into degrees, so you get a degree output. Everyone got that? Because you can search for XLS design.
You can say what formula you use.
So it's the distance of the tan of the angle, the tangent of the angle. The distance times the tangent of the angle.
Distance times tangent of the angle.
Yeah. Off the horizon.
Yeah.
Off the horizon.
Yeah. So
this is at 0 degrees.
And the tangent of the angle that we already know to calculate apparent height.
Mm-hmm. Yep. based on a flat Earth, then that would resolve at 3958. I didn't just pluck that number out the air. That's what the triangle would necessitate for 90 degrees over 69 miles per degree. All done?
Thank you, Gleam. Appreciate that. So, I have no doubt Brian has worked something out, and I look forward to seeing his video. I know it was a little confusing, but I think he was having a real problem with the video there and the technology.
Brian is the ghostwriter for Joe Biden's speeches. Thank you very much.
Anyway, all right. Well, we'll open the panel back up to the ballers. Ruhip was already here, so he kind of broke it open anyway. And
that was crazy, by the way, Brandon. I don't get what we had an exchange in the inbox in Discord, and it just got to the point where I was like, Ruhip, you're wasting my time, mate. Everything I was saying, he was going, "You're wrong. You're absolutely wrong on that." And I'm like, "No, there's a difference." You know what I mean? You should have noticed that, but. Forget him, he's just an obfuscator.
Yeah, that's all he'll do, and he'll never even acknowledge that that you're anywhere close to having a coherent point. He'll just say, "No, you're wrong. No, you're wrong. No, you're wrong. No, you're wrong," and then he'll act like he doesn't understand what you're trying to say. It's very, very frustrating and annoying.
I had an exchange with him in text last night. With that, that spinning top in the smoke bubble thing.
Oh God!
And I said the gas will never get to the same speed as the spinning solid object. And he's like, "Yes, it will. Of course, it will." I said, "No, it won't." I said, "It'll spin. It'll never reach the same speed ever." And then he said, "Yeah, but what will happen is the difference between the two will be called wind."
Oh,
and all I could say was, well, thanks for agreeing with me, because you've just admitted that they won't. So first of all, they would get to the same speed, and then he admitted they wouldn't get to the same speed, and the difference would be classified as wind. So you're right, it's just obfuscates and double speaks, and it's almost, I swear he's almost a professional at it.
No, he is.
But I don't know.
He is a professional of some type. I don't know if he's a amateur professional or if he's a professional. You know what I mean? If he's paid.
Yeah. That's it. That was my point, Brandon. Yeah, which level of professional? I don't know.
Funny.
Right.
Yeah, I mean, if you look on my screen there, this is what I showed him. And when you change the sensor image size from his 5K to my 4K, both our maths perfectly matched. And his response to that was, "I don't care for your shitty calculator, online calculator." And I was like, "Oh, okay." He goes, "I can calculate it myself." And he just said there, this adds complexity. And I mean, this guy who's written this site, scantips.com, is basically a scanner expert and a professional photographer. Now, the reason why he says this is shit, and this is the most interesting thing, and I think I might have to zoom in for this one because you're going to like this one. This guy does things like measuring photographs. Very, 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 very good at testing stuff and testing how good photographs are. And look what he's highlighted. I didn't highlight that. Look, my highlight's that. He's highlighted this sentence. Wonder what this says. Let me zoom in. Let's calm down.
Now, who highlighted this sentence in yellow?
He does. This guy who owns
guy.
this website. Yeah, the guy who is a professional photographer and somebody who does like scan imagery and perspective distortions and stuff like that. And he's done calculators for all things to do with cameras, but like the focal lengths and stuff. But the camera obviously achieves its camera purpose, but it simply is not a precision measuring instrument. Do not kid yourself when the calculator shows precision of a couple of decimal places. If you do need precision measuring, you should get a different instrument intended for the purpose.
Interesting. That's funny. Ruhip didn't like that, huh?
Bev needs to hear that. He'll like that.
So the camera told him it was 12 feet, but in fact, when he measured it, it was 30. So don't trust the numbers on the camera, especially not in zoom lenses. Oh, what did they use on Blackpool? A 300mm zoom lens.
Yeah.
That's fun.
Wow.
But yeah, I've got others
That
which are
says
like
everything.
which are like people doing it the same way. Like amateur professionals, if you know what I mean. Sort of like people, and this has been taken off the web since I found it. So I got it on Web Archive. But he does the same thing, and yeah, for all practical purposes, you can get a near. He basically, this guy draws up scripts and actually puts his photo and perspective distortion, corrects it in Unity. And what he finds is he tested on his house. The window that he was measuring is 77 inches tall, and the camera method measured 79. So he was two inches out, but that's a 2.5 inaccuracy, which is close to the rangefinder's inaccuracy at that distance, which is about 3%. Now round that up to what, 81 kilometers? What percentage is that? I just said it to conspiracy cats. I hope you got it in the thingy. Is note the ratio of how much of the mountain is hidden versus how near the Blackpool Tower is in comparison to the total distance.
Oh, would it be within 2.5%?
Yeah, 0.25. 0.25%. They're both that same figure within there, within a couple of hundredths.
You know, it's too bad that Ranty didn't come and talk to you about that. I wonder if he is aware of this information. I wonder if he considered this.
Who
Yeah,
cares?
imagine if he had came and asked the community. And
Who cares if you've got an
him.
agenda?
Yeah,
Who cares if you've got an agenda?
True. Yeah.
Watch a
Well, it
video.
makes things pretty obvious, doesn't it?
If you watch a video he dropped, he's trying to bait people to going after him. Don't take the bait. Well, like apparently flat earthers are all piss drinking cultists who follow some sort of rules.
Boycott his channel. It's we gave him we accepted him. Said okay, if you want to go back to the ball, fine. He might have had a few trolls giving him a hard time, but
this is what they're looking for. They're looking for flat earthers to get sound bites of them saying nasty stuff back to them, so they can try to make it seem like flat earthers push people out with alternative points of view.
Yep.
It's baiting.
Yep.
Okay. It's all bait. The whole
so
video.
don't fall for it, people.
Yeah, just take these guys with a grain of salt. I know, especially for people who are new in the community or aren't used to dealing with conflict, the barrage of just idiocy
I'm
and
not listening to you right now.
nastiness that people can hurl at you.
I have no idea, and I'm trying to listen to something else.
Huh?
Hot mic.
Nastiness in this arena can be overwhelming sometimes. Don't take these people seriously. They will try. They'll say anything they can to get under your skin and to make you feel like shit. You are better than that. Do not listen to these people and just take them with a grain of salt. They're ridiculous.
Yeah,
laugh at them.
Here's a case of this. What I was doing. The case in point was you had WS and Shady, that General Shady, talking about that they're going to do a GoFundMe for $20 for each tooth, or I mean $200 for each tooth someone can knock out of my mouth. Like posted directly in the general chat, and then like I'm supposed to be scared of that. Like you're going to try to find my personal information and track me down.
Well,
this is what they do.
Cool. Where is that at? You'll have to send me a link.
Yeah,
to that.
that's fucked up.
Oh yeah, I'll like it's still up in the general chat even.
Yeah. Okay. Anyway, so yeah, floor's open. Anybody wants to talk about something? I've got to go deal with something real quick, so I'll be off mic for about 5 minutes. You guys can just talk about whatever you want. Anything.
Yeah, I just posted the link directly to it with everything before and after in context.
I would have thought there'd be a baller or someone who would want to say something about what they just heard. You know, people like Sean Hawkins, who go around asking for measurements to Polaris. You know, like, where are you all?
Seriously,
Why
try
aren't
to
you knocking,
debunk that same
knocking the
maths.
door down with your great argument?
Yeah,
So,
it
hear
was
me.
funny though. Hawkins tried to debunk that same maths with a cardboard model, and it was hilarious. His sort of like 60 degrees was pointing 60 degree the opposite way. Mental.
Yeah, you're there.
Yeah, here, look at, like, here, there's the best thing, crit. I'll know where you are, what you look like, or you'll never see me coming. I might be the guy next to you buying coffee or KFC. You'll never know. Enjoy. Yeah, these people are they're not scary. Okay, they think they're scary in their mind, like somehow, but they're only dangerous to themselves. Is really at the end of the day.
They're like them clowns that jump out on people. You remember that phase that went through about a couple of years ago? Yeah, they're like the ones that get knocked out straight away.
And he did this because there's a moderator on the server called WS, and he was fanning the flames, making it sound like I was being uncivil. So he's just, just doing what he thinks I deserve. Based off their atheism subjective logic.
They were all probably the
They
same
have
account.
no arguments anymore. They know it. They're backed into a corner and they're angry. I'm not, darling. Not at all.
So what is the apparent size of a tree that you 100 feet from and the angle to the top is 45 degrees?
So what, now you guys want our answers?
It's a bit of a litmus test, that's all.
Was asked before, never answered.
Just a litmus test. If you can do the basic, then it's possible you can do.
A super chat from Gordzilla37 came in a while ago. Thank you, Gordzilla. You said thank you to Brandon and company for the show. Much appreciated. Thank you very much, Gordzilla. Thank you for listening.
Of the angle. Simple.
Yep, so
What is
what I
that
had in
size?
mind is a known distance and a known angle.
Here I give you one.
Go on.
100 feet and 45 degrees. What's the height? Apparent height.
100 feet.
Yep.
82.843 feet.
Sure.
Why is that funny exactly?
That's easy shit. That's easy shit.
That his answer?
I told you they would just hand
What the
wave
fuck kind of
anything
answer is that?
like it's ridiculous.
Go try it. Go try it. Haley.
What was so funny, Cheeky?
Yeah, I don't get the laugh.
Yeah.
That's it.
Take a meter. Measure 1 meter. 45 degrees. Measure the height. And see what you get. Did it be 83 centimeters?
It's 83 feet. I've done that using an angular size calculator.
You actually don't need a calculator for this. If you know your angle
Actually,
looking up to the top of the tree is 45 degrees, you really don't need a calculator. Okay? That's how you're going to get the 45 degrees. It's going to be the same lengths on the
genius or something.
I don't question, but the purpose.
So anyway, is anybody going to address Gleam's argument, or you guys just gonna ignore it?
What was the argument? I didn't hear it.
You didn't hear it, huh?
Times 3100 divided by 12 divided by 5280. That got like 60 degrees.
Yeah, not that one. That one. What Gleam just presented. You didn't see it, RC? That's okay.
You mean me? I said I didn't. I saw Leaky what Leaky did, but I don't know what Gleam's
Hey,
argument
RC
was.
Meisty, that you? How do you calibrate a water level?
Was that the argument?
No, I don't want to go through it again because he presented for like 15 minutes. It was good though.
It's biodual.
Oh, it's
Yeah,
biodual.
I don't know. I don't know what Gleam's argument was.
Biodual is currently working closely with chemo to
Not doing shit with chemo.
Cavendish
Chemo's not
and
doing a
advance.
goddamn thing. But anyways, what was Gleam's argument?
I've just put all the raw data in the chat.
Go and watch
Okay,
it.
thank you.
We've all just been through.
And I'll do the formulas as well, so you can just copy and paste into Excel.
No, I understand Sokotoa. It's fine, but I appreciate the data. Thank you.
See how he just dropped Sokotoa there? Like, oh wow, I'm fucking badass in trigonometry.
I'm sorry that there's a quick term to refer to all the calculations. I'm sorry that there's something quick that you can refer to and say to show that you understand. It's all good.
Yeah, that didn't really save me
And the
there.
tone of voice
Yeah.
does stuff as
That's
well.
hilarious,
not
dude.
just
I never even made it to the trig, and that's the easiest of the fucking math. I even made it to the trig, just trying to convert latitudes to the equator to the North Pole. Just threw me for a fucking loop, and then getting cut off this. But I'm always done with this, and I'm gonna redeem myself before this shit ends. It's only gonna take me about 3 minutes, man. But yeah, the trig ain't hard, man. I'll do a little video on brushing up on that clarification. If anybody hadn't brushed up on it yet, man, it's not really that hard. I mean, they'll have us doing unit circles and shit next, dude. Fucking, it's just a stupid conversation. It's an insulting conversation. You can't teach common sense, you know. You can teach trig. You can't teach common sense, man. That's how we like to keep it on this channel. It ain't about who could do the trig shit, dude. I'm sitting here doing 10,000 papers, and right here on the spot getting cut out of videos. I can't even fucking multiply, dude. But
How do you do
but I'm gonna get
trigonometry
it.
on a sphere?
Huh? What, Rob?
Well, they all claim to do trigonometry, but you can't do trigonometry on the sphere.
Yes, you can.
You can. I thought it was with triangles. How do you do it on a sphere?
Yeah. The triangle, the base of the triangle does not have to equate to the ground, right? I sent this
Then it's
video
not
to
a
Paige the other
triangle.
day.
Okay.
You can make triangles
Then
writing
it's
of
not
triangles.
a triangle.
I understand that a curve.
Oh, you're cutting out, Rufus.
Sorry, hang on.
Okay.
Oh, that's better. All right.
Yep.
Yeah. I understand that a curved surface cannot be the base of a triangle. Do you think we are stupid? Rhetorical question.
Yes. Yes.
Exactly.
Absolutely.
No, I don't think
we-
you're stupid. I think you're dishonest.
Oh, okay. Fair enough.
Bit of both. Bit of
It's
both.
got to be
Is
one of the
Paige-
two, doesn't it?
So,
I've
Paige,
got a
have you
question
watched?
for Gleam. Sorry.
Yeah, I wouldn't say you're stupid. You're just spiraling and triggering because of something you think someone else thinks, and you're not
Paige.
thinking anymore.
Paige, have you watched my video that shows you how to do the geometry?
No, I haven't.
Okay. You should, and then you will understand how to do the geometry on a sphere or a circle.
When
or
I
whatever.
have a spare half an hour, I will.
Okay. Thank you. It is easy.
Yes, it is.
Have you finished, Ruhiv?
Oh, I was going to have a go at Gleam as well.
Okay, go. Well, I've got a picture
I was
on
going to have a
screen,
go at Gleam.
which is basically the
Yeah.
question you were asking him. I've
Yeah.
got the question you were asking Ruhiv on screen for Gleam. If you want to use my picture and use
I'm
this.
driving.
Use
What
this
was the
picture.
question again, man? Ask me the question real quick. I always know what I'm doing, but
All
I
right,
don't want
so-
to go unanswered.
Gleam,
What was the question?
Gleam said this. Gleam said his. Oh, can you stop echoing? Whoever? Jeremy or Brian, I think it is.
Yeah, it's Brian's.
Yeah.
mic.
Brian.
Brian.
I never echo. I'm on AirPods.
All right. Yeah, same. So I asked Gleam whether this trigonometry applies to things like trees, buildings, and mountains. He said yes. So I said, if you are 100 feet away from a tree and the angle to it is 45 degrees, what is the height of the tree?
How much refraction is there?
If the height of the tree, if you're 100 foot from the tree and it's 45 degrees, then the height of the tree is 100 feet. You just told me the fucking height.
Excellent.
It depends on how much refraction there is, though. It's not. I don't think it's as clear cut, is it?
Not in my model.
Let's
My
ignore
model
refraction.
doesn't start. My model doesn't start till like right at the horizon.
Could we have some super heavy refraction in between us and the tree, and maybe it's not?
Let's just assume no refraction for now. We're just doing geometry.
Ah, we're gonna assume no refraction. Okay.
Yeah, just to make my point. All right.
Hey, Rui, if you see what I was talking about the other day, though, how y'all do the trig, how you did the trig, you got to admit that was an error. How you did the angles at the same height, based on the trig, and then you drop. It wasn't a big error, but then you dropped the viewer height and applied it the same to both of them. That was an error, right?
I've sent you direct messages, right? You can respond to those. Gleam. So we agree that the tree is.
I didn't see them, Riv. Sorry, man. I really didn't,
Well,
but I
check
will.
your messages. Okay, that's fine. Yeah, then can you go on mute so I don't have to hear myself? So we agree that this tree is 100 feet away. It's 100 feet tall because the angle is 45 degrees. All right. In Gleam's figures for Polaris, at 45 degrees latitude, you're 3,100 miles away. Gleam, well, therefore, the height of Polaris is 3,107. It's the same, right? Same as the distance.
Apparent
height. What is this apparent? Why didn't
it's where it appears to be. Take that tree, take that whole distance, yeah, and just pretend Polaris appears at the top of that tree.
Yes, that's what we're doing. But
so the tree's not changing size, is it? But the apparent size of it is.
No, the apparent size is an angle.
Oh my God, I know this.
Oh, Ruhif, this is really bad, mate.
The apparent size is the angular size. It is measured in
degrees. Not once you get to the horizon.
Think about this a bit more.
Rip, by the time you get to the horizon, man, and everything converges, then everything acts the same. So then you have to start. You know what? I'll explain that later.
Anyway, Rumpus, you do the arctan of the y over the x to get the angle.
If I go twice as far away, if I'm twice as far away, so not 45 degrees latitude, if I'm at the equator, the angle.
Ruhiv, I think you need to go and look at the maths, mate, and then come back with the problem with it.
I have.
How long? How long ago? How long have you spent on it? How long have you spent on it? Sorry.
I asked you on Discord, what does the apparent altitude mean?
Sorry.
And you have no idea.
Have you looked into it? The maths works. You don't know
numbers,
how it works. I've explained how it works.
Sorry, Glenn, can I ask Ruhi, does he agree that when you move, Polaris appears to drop down in the sky? Do you agree that happens?
Yes, and it's described by trigonometry.
Yeah, which is what Glenn's done.
No,
he hasn't.
We understand.
He's done it wrong. I'm trying to show that on screen.
He just changes.
You just told me I got it right, Rumpus.
Well, hold on. Let's just go through it.
It's where it appears to be as it's dropping down, so it's perfect. It's still the height that it actually is when you're 90 degrees under it, but as you move away, it appears to drop down. So it's giving you the apparent.
Rumpus and Ruhif.
That's it. Oh my God, Ruhif. Honestly, mate, this is embarrassing.
This is getting too convoluted. Very quick. You explain. You explain. Yeah. We'll explain what's wrong with my maths. Yeah. No, you've asked it, and we've just answered it correctly. So just explain what you're going to explain. I'm bored of answering questions with no fruitfulness.
So here we go. This is the question that Ruhif was asking. What is effectively, if you've got a tree, what is the angle? So we're only interested in the angle, and Gleam has just given me the answer.
We're only interested in Polaris.
Well, no, we're going to go see if we can do a tree first, and then we'll do Polaris next.
Yeah, something completely different. A physical object on the ground.
But they have the same basic geometry page. That's the point that Ruhif was making.
Then do it with Polaris.
No, we're going with the tree first. No, we're going to do the simple case first, and then we're going to take it onto Polaris. So I think. No, hold on, George. I'm trying to speak for 5-10 minutes.
Okay, all right.
Can I just get through this
before? Go ahead, but I have a comment after you.
Is it quick, George?
Yeah, very quick.
Quick, go ahead.
Yeah, if you're looking to Polaris on a flat plane or a flat Earth, the Y would be extremely much larger than X So all the angles you're going to measure to Polaris on the flat Earth are essentially 90 degrees, no matter where you are on the flat Earth.
No, they're not,
Rubbish.
George, because the Polaris is only 5,000 K up in there. Things. In fact, the distance X is actually much greater.
No, Polaris is 450 light years away.
No, they think it's 5K.
Not in our model. Stop putting your cosmology on top of our model, George.
Yeah,
for
George,
fuck's sake.
thanks for
Burning
that.
straw men.
So you're sabotaging there, George. Well done. Right. So
Yeah, well done, George. Go ahead, Rumpus.
Right.
Go
So
ahead, Rumpus.
here's the question that Ruhif was asking Glean, just to see if he understood the most basic bit about trigonometry. And because we're trying to work out the angle to something, Ruhif was asking, so Glean, can you give the answer? Now he gave, I think, Glean, was it correct? You said arctan. This is the formula for the angle. What is this what you said? Oh my God, is he shut up now?
That's what he said. He said it's the arctangent of y
Yes.
over X.
Sorry, I was
What
speaking,
was
but I
the
was
question?
muted.
I'll answer-
Arctan of y over
Why
x.
are they asking these questions, man?
Right, because we're establishing whether Glean has the most basic understanding of trigonometry.
So you're trying to catch him and
Brian,
and
will you
he just-
stop? Brian, I'm trying to talk to Glean. Could you shut up for a moment, then we'll get back to you.
Dude, it's
And you're echoing
Sokotoa,
like
dude.
crazy.
It's not
Brian,
fucking
you're
rocket
echoing
science.
like crazy and wrecking this.
All right.
Right, so we've established that Glean has actually given me the right answer. Now, whether he knew that before or looked it up, I don't care. That is the correct answer. So that means that that is the angle, and there's no need to introduce anything to do with apparent sizes. There's no need to measure y is the absolute size of the tree, and x is your distance to it. There is no need to introduce any modification to y. None.
Except for this.
Zero.
When it
And
stops
any
rising
attempt
up,
to introduce any
Rumpus.
modification to y is an error. So
Rumpus,
now
once
I
it
will
hits the
show you-
crosshairs, it quits rising up, so it's not.
I'll do in a second. I just want to
All
finish this now. I now want to go to Polaris. Right, so if we do Polaris, so here's the situation with Polaris, where there's believed to be 5,000 kilometers up, apparently, according to flat Earth sort of maths. This is the same situation. So the formula for the angle is a similar formula where you put in 5,000 for y and you divide by s. That there is the formula for the angle to Polaris. It does not involve anything to do with the apparent height or any other bollocks. That formula is complete. And Glean doesn't use it because he's a moron or whatever. That is the correct formula.
Lost the debate.
You didn't
See you
understand.
later.
What you did is the reverse engineering.
I reversed the
Because-
Yes, I
angle.
know. It's
Yes,
irrelevant. We
because
don't want you. We
I
want you
know
to
the
calculate.
angle and the distance, I get some height, which is not the height of Polaris, which is the apparent height.
It's apparent
Something
height.
no one ever heard of apparent height.
Yeah, it's gibberish. So the point, yeah, but his formula was supposed to be giving us an angle as a result. He's trying to determine the angle to Polaris at different positions of x.
No,
i.e.,
the
I've got here along
distance.
here.
No, you don't know the maths then, sorry. It was to find out the distance, not the angle.
Well, it's gibberish. You were drawing.
Yeah,
the
it's
wrong
gibberish because you don't know it. You
don't
don't
know
know what is
trigonometry.
actually even trying to do it.
Yeah, but the point is, if
Oh,
you know the
Rumpus,
distance height
please.
of Polaris,
Give
if you
over,
know the
mate.
height of Polaris,
Give
which
over.
presumably you do, you can't change the height of Polaris, can you?
Mate. No, I don't.
Look, you moron! You can't change the distance
I
of
don't.
Polaris. You fix it
I
at
don't.
one
It
height.
stays at one height, Rumpus. throughout the whole
Great.
thing.
So
Please
therefore,
look at the
we've
maths.
got a relationship between the angle and the distance, and
do
that is the one that you correctly identified as here. So the angle to Polaris we would
Rumpus,
see we're
right
changing
about now,
with
you're
S.
clueless to what I've
And
done.
you came up with a gibberish concept of apparent height when the apparent height does not change.
You've just been told what happened, and
You're a
you just
moron. Yes,
ignored
I've been
it
told
because
you're-
you know
you're a
you've just
moron.
been.
You're a
Yeah, if
moron.
you want a personal
You don't
attack, that's
understand
cool.
basic
You lose the
trigonometry.
debate. That's
No,
fine.
you're moron. You don't understand how to use trigonometry.
You know why you were on mute
No, you
before.
you don't
Because
understand
you-
how to use trigonometry.
Although
You're
you
a
just said I
moron.
was correct.
You know, you're correct in the formula, but you haven't applied it correctly, have you? Because the thing
How
you're
could he
trying
not
to
have
work out.
applied it
The thing we know in this is supposedly the height of Polaris, and that's fixed at 5,000 kilometers. That is the sort of approximate height.
You don't tell me how to do trigonometry. I tell you how to do trigonometry.
No, Rumpus. Hey, Rumpus, you got a calculator, man? Go. I finally got these things done, but for the case of my video not cutting off, it won't matter. We do. Let me show you what I'm working with, and
okay,
calculate these numbers as I call them out.
Hold on, I want to write your formula down first, Brian.
Okay.
So here's Brian's formula, and I want to know what this formula is. So here's Brian's.
Okay, 6 inches. Okay.
Hold on,
6
let me
inches.
write it down. Hold on. Okay, give me a second, Brian. Can you see what I'm writing? So here's Brian's formula. Now I want to know
Brian, mute when
so
you're
we've
not
got an
talking.
equals. So I want to know what's on the left-hand side. What does this formula give me? Please tell me. So what's on the left-hand side of this formula?
Wait, I can't see your screen, man. Hold on, man. Let me get somewhere where I can see you. Okay. Hold on. Wait. Okay. Let me. Let me
showing
see if I can
blank
get your screen.
equals blank. What's the first blank?
Okay.
Yeah. So what's on the left-hand side? What is this thing giving us? This formula of yours. What's it going to result in? Is it an angle?
But
Polaris?
there's a function of degrees.
Distance? No,
It's okay.
so
it's angles to Polaris. Polaris is Polaris is
So it's an
3,655 feet.
So we call it A, and I'm going to put underneath here. A is the angle to Polaris. Is that correct?
Yes. No.
Right,
A is
right.
the distance. Is the height of Polaris. Okay?
Well, get it
I'm not
right,
doing
Brian.
angles. Dude, I'm not doing angles. We got a formula for angles.
I don't think you're cut out for this, Rumpus.
Right, Brian. So A is not the angle to Polaris.
You will never become a teacher with this
No,
app.
it's not the angle. It's the height of Polaris.
Fuck
Okay,
that,
good.
Rumpus.
And
What
I
the
hope he listens for a minute though.
Shouter.
I hope he listens for a minute though. I mean, okay, so I got this worked out. So what happened is I fucking reversed the degrees, trying to get the latitudes to match degrees. So I'm gonna do it the simple way and just do the degrees from distance from the North Pole. Okay, so 15 degrees ain't latitude yet. We can easily switch it. 15 degrees just has to do with it's 15 degrees away from the pole. So you can do the 15.
Can we move on to something
Hey,
else?
Brandon, can I work with Brian on this? Maybe I can extract the
Can you work with me for a second, real quick, Brandon?
Sure.
Okay. Now follow me for a minute, though. Follow me for 1 minute, George.
Wait. Stop a minute.
Oh, another one throwing his toys out the pram.
Please.
Yeah.
What are we trying to calculate?
Okay. We're trying to calculate. Well, we're not calculating yet until I give you the facts, but we're going to calculate the angles to Polaris.
Ultimately,
we're calculating. We're going to start with the angles to Polaris.
Angle to Polaris.
No, I'm asking. Oh, please, Brian, listen. What are you ultimately trying to calculate? Not what we're starting with. What do you want to end up with? Angle to Polaris, distance to Polaris, the color of Polaris, whether or not Polaris has emotions, what?
Okay, first off, I'm going off of I'm basing
don't.
I'm basing the shut the fuck up and let me answer, dude. Dude, you're gonna
what
listen,
are you trying to determine?
Throwing their toys in that tram.
I'm basing the distance from the equator to the North Pole to start with. It's 6,200. Okay?
Brian, you're not listening.
How can I equate something if I don't give you numbers to fucking equate, George?
Okay, let's try it your way. All right. What are you starting with?
6,200 miles from the equator to the North Pole.
Okay, so you're starting from the distance from the equator to the North Pole. Okay. Now what?
Okay. Now with my refraction model, okay, or just with trigonometry basically, and the refraction model, I'm getting a height of 3,655, and I'd like to tell you my little model real quick. It's pretty simple, but and then I just want to run a few numbers by me, and then you could criticize all you want, but I just want to at least get these numbers out
Well, I'm trying
the way they're
to
supposed to have gotten
understand
out.
your calculation. So we're starting with the distance from equator to North Pole. Okay, and what is that distance?
From the equator to Polaris to the North Pole. To the North Pole, I meant directly underneath Polaris is 6,200 miles.
6,200 miles. Okay, so that's what you're using. Now what?
Okay, now Okay. Now I have I have a function of so I'm using 6 inches per mile squared of standard refraction. Okay.
6 inches per mile squared. Okay.
All right. It's a function. It's a parabola though. So your first 4 degrees, and basically your last 4 degrees are the same basically. But it's 100%, and this is where I need a little bit of help to get it exactly perfect. But it's real close on a graph. But so it's 100% to 4 degrees. Okay, the first 4 degrees is 100% of the 6 inches. Okay, 5 degrees is 99%. 6 degrees is 98. 7 degrees is 90.
Well, what is this
97, 90, 95, 94, 93.
Wait. How are you measuring this angle?
I meant no, that's percentage.
What? But you're talking about percentage of degrees. Of what degrees?
Yeah, that's percentage of the degree of refraction. In other words, the lower you are to the ground, the higher percentage of refraction you're going to have.
Oh my!
I mean, the lower you're looking in the ick. In other words, when you get up to 90 degrees, you're going to have 0 refraction, right, George?
Okay, so you're talking about viewing angle from the horizon upward.
Yeah, viewer angle toward the horizon upwards, right? Exactly. Sorry, I should have clarified that.
So if you're at 0 degree, at what degrees to get 100%?
4 degrees, 1, 2, 3, and 4 is 100% refract for the Polaris.
Okay, so you're measuring your angle from the horizon to, well, basically.
I'm measuring from my location.
I think the angle you're talking about is if you're up above the Earth and you're viewing something in the distance, the angle is the object.
Let me clarify that.
Just a minute. The object in the distance will be your vertex of the angle, and the sides of the angle that you're measuring is from the object.
Right, but the vertex is
the you and from the object to your eye. Is that correct?
Right, but the vertex is the theta is the observer. Okay, so that's why I gave you a distance to start with. Yes, the theta is the observer.
Oh God.
Okay, so we're looking off toward the horizon. So I'm starting at 15 degrees. I'm starting at 75 degrees away from the North Pole. 75 degrees. Okay. It's almost overhead. It's almost overhead, right? No. And in fact, I'm gonna start by the North Pole. I'm gonna start 15 degrees from the North Pole. Okay. You call it latitude, call it whatever you want, but you have to switch it afterwards. But 15 degrees from the North Pole, and I got so just to make it in the middle, 45 degrees. I got 3,100 miles, right? 3,100. Yeah, go ahead.
Right. One of the problems that we've always had with you is you're all over the place. You don't
I know I am, man.
Focused.
I know I am, but at least you're listening, though. Rumpus wasn't even listening, so you see where I'm going with it, though, right?
I don't have a good picture of what you're doing with what angle you're actually measuring.
All right. Well, look at my camera real quick, and I'll show you the numbers. Okay.
Your camera.
Hold on. It won't even let me, man. It won't let me, man. This is insane.
No,
Anyway, George.
Anyway,
just listen real quick. Bear with me for 1 second, because it's real easy to go over the numbers once we have them established.
Brian, when you make your
could I draw a little diagram and have you point out the angles to me?
I can't even show it, but I have them all written down. If you go to YouTube, you could get a picture of it. But let me just say one thing, though. Since we've done all this, let me at least do this, George. Let's say we're Polaris is 6,200, or the North Pole is we're saying it's directly underneath Polaris in our model, okay? And it's 6,200 miles from the equator. So halfway at 45 degrees is 3,100, right? I'm just saying that to make it simple, okay?
Yeah. Okay.
And so then 60 degrees from the North Pole is a little further. It's 4,132. Just what Gleam said.
Hold on. What is the height of Polaris?
Ground level.
The North Pole.
It's 3,655 feet.
3,655 feet. That is the distance that you are claiming Polaris is above the North Pole on the Earth, correct?
Yes. Yes.
Okay. All right.
Okay.
So
Now,
when you're 6,200 miles away, the angle that you're sighting for Polaris with respect to the horizon using this model that you are talking about would be the arctangent of 3,655 divided by 6,200. So if I take the arctangent of that, the angle is 30.5 degrees.
You're taking the adjacent, man.
Pardon?
Yeah, but here's a refraction formula that needs to correct.
Yeah, you got to hear this real quick, okay? Just listen to it real quick, okay? And we don't got to start at 0 because that's 100% of the 6 inches. You could easily see that that's right at being gone, okay? We don't need to do no math to know that 6,200 at 6 inches per mile squared, it's going to be gone or right by gone. So we'll start at 15 degrees away from the equator, okay? And what we have is what we have here
Wait, what do you mean 15 degrees away?
We have
from
5,164 miles distance from the North Pole.
What do you mean by being 15 degrees away from the equator? Are you talking a line of latitude, 15 degrees north? What does that mean?
I'm 75 degrees away from the North Pole.
In terms of latitude?
Yeah.
Okay.
And so I got 5,164. Depending on how many decimal places you get, but just go with that for right a second. You know, we can scrutinize it with decimal places. I think I did put like 3 decimal places. I think.
What you're basically telling me, okay, you're using about 69 miles per degree of latitude. Okay, you're using 68.
Yeah, pretty close. Pretty close, man.
Yeah. Okay.
Okay, so let's do this. So, do you got a calculator real quick? Will you follow me one time? Okay. Okay, so 5,164 times 5,164. So we're squaring.
So you want to square 5,164?
Yeah, and then multiply that times 5.34. Okay, that's
5.34. Okay. I got 142,000 or 142.4 million.
Million, right? Okay, now divide. Don't clear nothing unless I tell you to. Okay, now divide that by 12 to put it in feet.
Okay.
Then divide that by 5,280 to put it into miles. Okay, now what you got?
So
2,247. Okay, yeah, okay, so subtract.
2,247 and a half.
Okay, so subtract 2,200. That's our new refracted height. So subtract that from the height of Polaris. So 3,000. You can erase now. 3,655 minus 2,247.5.
1,407 and a half. 1,407 and a half.
1,004. Yeah. Okay. Yeah. Okay. Now just go to the triangle calculator real quick. So we don't got to do. Yeah. Yeah. Just go to Google real quick.
Triangle calculator.
Yeah. Okay. Okay. All right. Yeah, we can do this time. All right. Well, it's just going to be so much quicker, dude.
No, it isn't. Just tell me what.
All right. Well, okay. So now that number you have right there. Your new number. The new number you have, what you just wound up with, is put that in for your opposite.
Okay.
Okay. Now, your tangent.
So what's the adjacent or the hypotenuse?
Hold on, you got to figure that. Hold on. The tangent is 5,164.
Tangent.
Okay.
What? The tangent is what?
The tangent from the viewer was the original distance of 5,164.
Do you realize that the angle is almost 90 degrees when you have that large of a tangent?
Well, dude, just go to the figure.
No, I'm telling you. If
Yeah, it's
the tangent
75.
of an angle, if a tangent of an angle is around 5,000, the angle is almost right at 90 degrees.
Yeah, it's 75, man.
No, it's not 75. It's almost right at 90.
Okay, well,
There isn't
I'll
any
tell you
way
what.
that the tangent of 75, the tangent
I'm
of
just gonna go to Google
75
it.
is 3.7, not 5,164.
What? Say that again.
You
I'm sorry.
said 75. The tangent of an angle that is 75 degrees is 3.73, not 5,164.
I don't need all that, dude. You're giving me unnecessary information. Hold on.
Well,
Just hold on.
no, you
Okay.
just
So wait,
claimed
hold on.
that
Wait, George. George, what was the just listen now? Just listen to you now. Listen to me, please. What was the tangent again?
Of what?
Of 3,655. The height minus the refracted height of 22.
Well, the number that you came up with all that is 1,407 and a half.
Okay, 1,000.
407.5.
47.5.
1407.5.
Shit. Okay. Hold on.
1,407 and a half. That's after taking 1,000.
Okay, that's
164, squaring it, dividing by 12, subtracting off what you wanted.
Okay, that gives me about 77.
Dividing by 5,280, you come up with 1,407 and a half.
Right. 400. Okay, 1,000. Okay, no, 1,047 and a half.
1,000.
Yeah, 1,400. Gotcha.
7 and a half.
Gotcha. Okay, my information.
All right,
got
let's
crossed.
start again.
Yeah. Hold on. This time, follow me one time. Just follow me one
you
time.
The first time, and now you're disagreeing with the numbers.
Listen, just look, just take them numbers. That's 75 degrees, George. Do the fucking math.
The tangent of 75 degrees is 3.73.
Wait a minute, man. Damn it, dude. Hold on. Okay, look. Hold on. Let's start it.
Well, you asked me what the tangent of 75
no, man. We're getting
is.
different numbers. Listen. Listen. I'm using the triangle calculator. Listen, will you follow me one time just from scratch? It'll take just 1 second. Just follow me perfectly one time and then ask your questions.
I did. Let's go.
Okay.
Let's start.
All right. So what I'm going to say is this, okay? I'm 30 degrees away from the pole. I mean,
you give me the numbers and I'll do the calculations for you.
I'm 30 degrees away from the pole. Okay. I have 2,046 miles. Okay, 2,046 miles. Okay, so now do this with me. 2,046 times 2,046.
Wait. 2,000.
Yeah, 2046.
2046. Okay.
Times 2046.
Okay, so we want to square it. Okay.
Yeah. Okay. Times 0.9.
Times what? 0.9?
Yep.
Okay.
Okay. Divided by 12. Put it in feet.
Yep.
Now divided by 5,280. Put it in miles. You should come up with 59.4.
59.46. Yeah.
Okay. Now, so now we take the 59.4. We subtract that. That's our refracted hit. That's our refracted hidden. So subtract 59.4 from 3,655 from the height.
Okay. I get 3,050 or 3,595 and a half.
Okay. Now figure that in, and you get 60.1 degrees, which is exactly what it's doing.
Wait. I need to know another number to get degrees. What are you doing with this?
No, you got the tangent, you got the 90-degree angle underneath it, okay, and you have the height to it.
What angle are you trying to compute?
I'm trying to compute theta from opposite.
Oh, what is
opposite.
theta?
Theta is opposite the right angle, man.
Okay. So you're saying that the opposite is 3,655 and the base or the adjacent side is this 3,595 and a half. Is that correct?
3,005. Say the last one. 3,590. Yeah, that's close. That sounds right.
And a half.
Yeah.
So you want to get what that angle is then?
60.1, right? 60.1 or 60.3?
Oh no. Well,
oh yeah.
Here, hang on just a minute. Let me calculate it for you.
Just let the calculator do it for you, George. I started off doing it like this.
I don't need to use online calculator.
Yeah, but you're letting your pride fuck with my model, George.
We'll see.
We could have already went through every number, dude. We could have went through all 5 of them. I did 15, 30, 45, 75, and 90. Well,
okay, the angle is 45 and a half, or 45.47 degrees.
Okay. Now, anybody who is interested, go to the right triangle calculator. Go into Google, put in right triangle calculator. Okay, and then what you do is for side A. Listen, A is
Brian,
what?
Brian, listen a second. You're saying the opposite side is 3,655, correct?
The opposite is 3,500 and what was it, 95? Is that what you said?
Oh, that's your opposite?
You told me twice. Theta is opposite of the right angle, George. You understand that. And since you don't, will you please go to the triangle calculator?
Brian, you've got something all haywire here.
No, you do, buddy.
Listen, Brian, just listen, please.
This is cool because I embarrassed myself earlier. Now you embarrass yourself now. Anybody listening wants to go to the triangle calculator. Side A is 3,595. Okay.
Brian, this is why people don't talk to you, because you won't let one have a word in.
Back at you, man. I just give you the numbers and you won't apply them, dude. And you won't let me do it verbally.
What you're calling opposite of.
Who cares what we're calling? Go to the calculator and I'll describe it. Theta is opposite. Okay. Theta is opposite the right angle. Okay. So you know that we're doing viewer angles to Polaris, right? We're trying to figure viewer angles to Polaris.
Brian, here, calm down a minute, Brian. Okay, I agree. Well, you can't say theta is opposite the right angle. There's two.
Well, why don't we just figure? Why don't we just figure out the sign?
Brian, in a right triangle, there are two acute angles besides the right angle.
But you know which one I'm looking for.
Right angle.
If you had common sense, you'd understand where we're standing on the Earth according to this triangle.
So you want to calculate the angle that
I've already done it, dude.
Brian, shut up. What you are calling theta then is the angle that you make from the horizontal to Polaris, correct?
Yeah.
Okay. Now, the opposite side of that angle, according to what you've been giving me, is 3,655. That's the opposite side.
Minus 59.4.
Okay. All right. So we'll do that. We'll use that number. So that
35.95. You've already 0.6.
and a half. Okay. Now, what's the length of the base? The horizontal part.
The base, okay? Was the first two you multiplied times each other. Okay, so it's 2,046.
2,046 is your base. So you want to know what theta is then. So I've got 39 or 35.
I already know what theta is, George. It's 60.3.
Divided by 26.4, and I take the arctangent, and I get 60.36. Okay.
Right. So if you're 30 degrees latitude away from the North Pole, by this model, you're looking 60, just almost. That's about probably the worst one. It's 0.3 off of exact. Okay. And do one more with me now that we're on the same page, man. And okay. So 45 degrees. And I want to show you my graph before it's over with. It's a it graphs like a parabola, but it needs a little tiny bit of help, man. And I know you can do
It
this.
needs to be a circle, and it will be perfect.
So we should be able to do this pretty quick now that we understand. I'm just blaze right through the numbers, okay? So now we'll do 30 degrees. 60 degrees, okay? The one Gleam said was 4-1. Okay, I got 4-1-3.
So this first one was at 70 degrees north latitude or 30 degrees from the equator, correct?
No, it was 30 degrees from the North Pole.
Oh, from the North Pole. Yes, that's what I meant. Yeah, so it's 70 degrees north latitude. Okay. All right. Now what?
Yeah. No. It's 60 degrees north latitude. It only goes up
60.
to,
I'm sorry. Yeah, 60. I'm sorry. Yeah. Yeah.
Okay,
30 minus,
okay, now-
90
so
minus
now our-
30 is 60 degrees. Okay, fine. All right. Now what? You
Okay,
want to be what?
so
45 degrees the way you're saying?
well, we've already did 45 degrees. It's that one's cut and dry. It's pretty simple, so we can skip that one.
What do you want to do next?
But if you want to know, 45 is half the distance, so it was 3,100. So if you want to do that later, it's
Oh, that's
3,100
fine.
and it refracts.
Let's move on. What angle do you want to
Okay,
reach now?
now we'll do 60 degrees away from the North Pole.
How many?
So
60
degrees away
60?
from the North Pole. Yes, sir. And
Okay.
my distance is on my map is
So you're going to
4,100.
be at 30 degrees
30.
north latitude.
Correct.
Okay. All
All
right.
right, and
Give me your
it's
number.
4,132 miles is my distance.
4,132.
Yeah. And so I'm gonna multiply that
From the
times what's
equator?
the
Oh, no, for the base, you mean, for the base.
yeah, from the ground, from my viewer height at sea level. So 4132
Oh,
times.
just a minute. Let me verify
All right,
that. If
all right,
I
all right,
take
all right.
Just a minute. Let me verify. If I take 30 times 69 and I subtract that from, what was the number you had? 6,000.
You don't really have to do. You don't have to subtract raw distance.
Yes, I agree. I agree with the number. Okay, move on.
Okay, so 4132 times 4132. We'll just blaze through this real quick. 4132 squared. So 4132 times 4132.
Got it.
Okay. Times 4.5.
4.5.
Correct.
Okay.
Divided by 12. Put it in feet.
Divided by 5,280. Okay.
Divided by 5,280. You should have came up with 1,212.
Yeah, I got 12.6.
12.6. So that's your hidden that's your refraction. So multiply.
Okay.
Subtract 12.6 from 3655.
Right. Okay.
And
So
tell
I
me
got
what's
2442.4.
2442.4.
Yep.
Okay, so 2442.4 is your A. That's my
opposite side.
That's
and
your
then I
opposite,
use
right.
4132 for my base.
That's what I was saying to begin with. It's opposite of theta. That's what I was trying to say anyway. But okay, and then you got 90
Okay, I
degrees.
get 30.6 degrees.
So that's it. So if you're at 30 degrees latitude and you're viewing Polaris, at about 30.6 degrees.
Yeah. Well, the real question in all this is these factors that you come up with, like 0.9, 4.5. I mean, how are you deriving those?
I showed it. Okay, and this is I based it. That's where I need a little bit of help. I'm trying to make a parabola. Okay, but it's not a perfect parabola, man. And I'll be honest, I ain't brushed up on my calculus. All I can do is like basic calculus to get what I got. But if you rewind it, I'll try and play my camera real quick. I got it all condensed onto one page.
Brian, the key to this is this factor that you've got in here.
Exactly.
So I just joined about 20 minutes ago, so I have no idea what's been talked about prior the past few hours. So
well, thank you for going over that with me patiently, man, because we were quick.
Right. Well, you'll have to explain to people how you're getting these factors, because that's the key to the whole thing.
Okay, this is what I come up with. Okay, so there's a little bit of explanation, but not much. Okay, the same way you would give an explanation for 7.6R. Okay, I give an explanation of a parabola for refraction based on it's a function of degrees above the horizon. Okay, so in the first 4 degrees, I'm using 100% of my formula. Okay, and of course, when I get to 90 degrees toward the opposite end, George, I've got 0 degrees refraction.
Yeah.
And in fact,
but again, Brian, I have no idea what you're talking about. All I'm hearing is words because I don't know this formula.
I know,
that you're
but I'm going to show you real quick. But let me just tell you, I'll sum it up. Okay, so what I did is a parabola from 4 to 75 because that's where my 0 stops. I did a parabola from 4 degrees or from 5 degrees to 75 degrees. I did a parabola, and then did my percentages based off that parabola. And so whatever percentage it was. So in other words, if you're at 15 degrees, okay, then let me just show you, man.
Yeah,
so it's a percentage of the 6 inches.
I have no idea how you're fitting this data from 5 to 75 using
Right, it's a percentage. The percentages is a percentage of the 6 inches. It's a percentage of the refraction. So the function of height it's a percentage, okay, of the 6 inches per mile squared. That's a function of, so in other words, you don't have the same refraction right on the horizon.
I understand it's a nonlinear function, but I don't know what this function is.
Okay, it's on the stream earlier, but I'll try and play my camera real quick. You're pretty quick without the fucking calculator, dude. I'll give you that, unless you were cheating.
I don't cheat.
It took you a second, man. Your first couple, unless you just totally wasn't but it took you a second to get in the groove, though, man. That's just, I don't know.
It's not a matter of getting in the groove. It's trying to understand your definition.
It's understanding it, right?
What you're defining as theta and what your opposite and adjacent sides are. Once I understand that, then I can go through this very quickly.
Right. I thought, yeah. So I wasn't describing my theta right, but I thought I was. I was saying opposite to the right triangle, but I understand the ambiguity there.
Angle to the right angle and the right triangle. There
Okay,
are
so
two opposite angles. That's what was confusing, is your terminology.
Right. Okay. It won't let me turn on my camera, man. Let me try this real quick.
Because just for your information, in a right triangle, we do not talk about opposite angles. There are no opposite angles.
Yeah, I know.
Just a minute. We talk about angles that are opposite sides.
Right, opposite sign. I know, man. That's why I was trying to clarify the viewer angle, so we'd be on the same page right off the bat. And you were trying to clarify one thing, and I was yelling back at you, trying to clarify the same damn thing, right? But opposite ways of doing it. So yeah.
But in geometry, the correct way to describe.
I agree with you. It's opposite of sine.
Is normally what we do, Brian, is you have 3 sides to a triangle and you label them A with lowercase letters, A, B, and C.
A and B. C is always the hypotenuse, right?
Yeah, but we use lowercase letters. Then
right. And then you use squigglies for the angles, right?
Brian, then we can talk about the angles that are opposite those sides.
Opposite and adjacent.
Those with uppercase letters, A, B, and C.
Gotcha.
Then we can communicate.
I understand all that, George. I know y'all don't think I do, but I promise you I do.
However, if this was of any use to us, we would see Polaris apparently move with respect to other stars as we move.
No. And here's why.
And hold on, nearly there. One more sentence.
Go ahead.
And circular star trails would be impossible everywhere but the North Pole. But go ahead.
Okay, so if you could get right to the North Pole, you could give me problems, but you'd have to get right there. And I also, I started my presentation talking about there's no significance of refraction until you get to about 62, 61 degrees. So if we're comparing stars around, and it's from state to state, refraction is not going to play much of a role because there's not much refraction. And if we're it's a little tricky, but I'm telling you, the Google Earth is not as on as you think. Trust me, it's difficult.
You would still see stars you would still see Polaris moving or apparently moving with respect to other stars as you move north to south. And I do not have to get right to the North Pole. All I would have to do is be anywhere on Earth that is not the North Pole, and I could not get a circular star trail by pointing my camera at Polaris.
What are you talking about? You get the same thing you get on a globe. That was the whole point.
Why would I? Because you're saying, hold on. You're saying the apparent position of the stars is changing according to perspective.
Yeah, no, if you move,
hold on,
it's going to change. Yeah.
Brian, I'm still talking. This means that if you point your camera at Polaris and you are at the North Pole, you're pointing directly up. You're going to get a listen, still talking, Brian.
Breath,
well, let me waste it. It's mine to waste. Okay? If you point your camera straight up at the North Pole, you will get circular star trails. But according to you, from that point south, perspective starts to play a role. So if that was true, you wouldn't be able to get a circular star trail anywhere else. It would be
why not?
It would be elliptical because perspective is playing a role. It's making it look flattened. It's bringing stuff closer together. That's at a greater distance.
Yeah, they're all going to look the same.
Jem, can I just
interrupt? They're all going to look the same from one viewer location.
This is
Brian,
true.
I'm going to save you.
They're going to do together.
Brian, I'm going to save you, mate. Have a look in the chat right now. There is 5 videos by Steve Torrance where he's physically gone out and took star trails and matched them up to his flat Earth model with Polaris about 4,000 miles.
Well,
with
so what? What's that got to do with?
Okay,
so Steve Torrance
you're saying it doesn't work, and he's made it work.
Well, I'm not
reality in both the north and south.
Okay, well, I don't know anything about Steve.
Rio de Janeiro, is that?
I don't know. Can I get this out? I don't know anything about Steve Torrance's model. I wasn't refuting Steve Torrance's model. I was refuting what's been presented here by you and Brian. If Steve Torrance's model is similar and also demands close stars, then it's true of what he is saying as well. And I can say that without even looking at what he's saying.
Yeah, that's a very good debunk. I can just say it without looking at
what
he's saying.
If the stars are close, that would
be
true.
Jem. It's game over, mate.
Can I respond to that?
It's not game over. It doesn't explain.
I'd like to respond to that.
In the south, I'm sorry.
You don't know nothing,
wherever I'm at. Okay, if I'm at 90 degrees, I've got 0 refraction. There's no significant refraction. Like I said, till you get down to 61 degrees. Okay, it's under 1 degree. Okay, it's a parabola. Okay, and so you're only going to be viewing from one location. So all the stars are going to move. There's no left to right refraction. They're going to look a certain elevation, and they're all going to move with respect with each other from that one location. So you get exactly what you see.
No, sorry, it won't work in the south.
Gibberish.
It's exactly the same as on the globe, pal.
Well, if perspective is playing a role, that would mean that as I move north...
Not perspective, Jim.
All right, refraction. What you're saying, I mean, it doesn't really matter, does it? I mean, refraction is even more unlikely because what you're saying is that conditions in the atmosphere ultimately are exactly the same all the time, everywhere.
Standard.
Exactly the same conditions where we can absolutely predict the position of any star in the sky.
I could then argue, Jim. I could then argue that. So you're 7/6R. Everything that you look at, 7/6R is always 7/6R, Jim.
No,
you're not being fair.
No, that's not true.
Yeah, exactly. No.
Someone doesn't know about stellar aberration either.
Yeah, so whatever angle it's showing you, that's what you're getting on a globe. You're saying that, so up in the sky, yeah, we're getting the same refraction up in the air, above the shitty horizon and below 60 degrees. They're out at a distance, okay? That's out at a distance. That's where we're going to get our refraction on the horizon. It's going to be the most.
But we don't say refraction is the same all the time, everywhere, every single day.
Yes, you
never
do.
Changing. No, we don't.
Yes, you do. Yes, you do. You say the sun is always ahead, and the stars vary because sometimes they're not even viewable at 5 degrees, Jim. And
right,
hold on, let me respond. And the sun is always already set, and we still see it. That's always on your model. So don't tell me. Why would you even say that?
Okay, when we get very, very close to the horizon, that's true. We know that we can't make reliable observations very close to the horizon, so we don't make observations close to the horizon. However, this is not true. This is not true of the rest of the sky, and your idea demands that it is. It's ridiculous.
You're saying your angle is.
It cannot possibly be
your
true.
angle is because of a curved
cannot
Earth.
possibly be true. And as usual, with all of these flat Earth ideas, it's completely incoherent with everything else.
It matches your globe. If you don't like it,
you've just plotted the position. You've just plotted the position of one star in the sky and gone, "Hey ho, I've solved the problem." You haven't.
It matches your globe, pal. I matched them all. I matched every fucking degree, Jim, from 0
match it
to
to every
90.
star. Match it to every star from every location. It will fail.
No, you say that your Earth is curving, and I say no. I say that freaking if we're looking at a star that's 5 degrees, and we're looking at a few thousand feet in height that's refracted, okay? And here's one more point, okay? And I'll end it with this, okay? So when we get up in hot air balloons and we see, you say obstruction, okay? And I say, yeah, we get obstruction a lot, okay? But we don't see curvature. So if we get up 128,000 feet and we can see out 1,000 miles, that's 15 degrees. The ground should be dropping away from me, okay? And there's about 9 degrees it should be dropping left and right. And it ain't there. You do get obstruction, yeah. You do get standard refraction, whatever, to make your shit work. Well, this is our standard refraction, man. And we don't never see curvature. That's my point.
It's obviously nonsense.
Yeah, obviously, because you've got the say on everything, haven't you?
Well, I've given him the reasons.
Just whatever you
simple.
say, you can just you can just
the reasons
see
are very
stuff
simple.
like what you just
Anyone
said to
can
me in the
see.
chat.
Anyone can see the stars are not
No,
close.
you're pleading.
Very, very simple.
Anyone can see. No, everyone can't see. Some people won't be able to understand it. You're an idiot. You're just saying words, thinking that they come true, and thinking flat earthers are just going to wander behind you like some Pied Piper.
If the
Just
stars,
stop being an idiot.
If I can get
Counter
star trails,
what he says.
If I can get circular, I have counted what he says. If I can get circular star trails at the North Pole by looking straight up, and as I'm moving south, and as I'm moving south, Polaris moves closer to the horizon, apparently due to refraction. Then obviously that this would affect Polaris and the stars near it differently to other stars
and
in the
trigonometry,
sky.
man.
And if I'm getting a circular star trail at the North Pole, and this is what's shifting stuff downwards towards the horizon, I'm not going to get a circular star trail anywhere else, am I?
You don't get circular star trails. You get arcs, Jim. You get arcs that are going from down to up. Okay, this is what you're feeling. This doesn't work on a globe, bro. Okay, what you're getting is an arc coming from the horizon, going to up in the sky when you're way away from Polaris. That doesn't work on a globe, bro. It works on a plane.
You honestly think that's true, Brian?
I know for a fact it's true.
You think that's true? So you think that
if you're under something that's 3,000 miles high,
let me put this to you that you're now saying is true. What you're saying is that the movement of the stars, which has been observed by humankind for millennia and recorded, and you're saying that there's some anomaly with this that cannot be that cannot be explained on a globe, and this has been spotted only by you and by no one else. This isn't a mystery to any astronomer anywhere in the world.
I had to match reality, Jim.
There's no like big problem of astronomy where they're trying to solve this issue. It's just you that spotted it.
No, first and foremost,
and you think that's a likely thing that you should say to other adults.
First and foremost, Jim, I had to match reality. Okay, first and foremost, my shit had to match reality. Okay, so you saying that it doesn't? Yes, George, we just went over the numbers, pal.
So what? Reality.
You're saying you said when we leave from the
reality
North Pole,
tells us your numbers are useless.
They're the same as yours, stupid.
Right, but your reasoning for reaching them is useless to us. If you're just taking our numbers and saying it's because of refraction, then what are you providing to us? Apart from something that we can test and show that it's not true.
Really? How are you
There's
gonna
some
do that
better
test?
arguments. They're out there. You haven't hit any of them yet, but there's a couple decent arguments. But you have.
Well, it's interesting, that, isn't it? Both you and Gleam have come in here with your big clever sets of numbers, and both of you have said, "Oh, well, actually, go and look at somebody else's argument. They've done it really well." Good job, guys.
Here's my point. My
they
point
modelled
is
it.
you just acted like we could see straight up to
In
Polaris
3D.
from the equator. It's not. That ain't how it works, buddy. It's an arc. Okay, so it don't work on a globe. So I had to figure something out. But I had to match reality.
Oh, well, take it to, I don't know, the Royal Astronomical Society, Brian, because apparently they've been trying to solve this problem for decades, for hundreds of years. You've come along and solved it. You're delusional, dude.
If you listen to the beginning, you'd see why
Think about what you're
this
saying.
in the first place.
Think
in the
of
very
the
first place, I
consequences of
started
what
all
you're
this
saying,
because
Brian.
of the possible eclipse, buddy. If you'd listened
Think
to
of
the
the
presentation from the
consequences
beginning.
of what you're actually saying, Brian.
Hey, Jim, why don't you try addressing the actual what he presented and the argument that he
I
presented?
did.
No, you're
I
just
did.
using this rhetorical thing. You,
All right, I'll
after
address
all
it.
these
All right,
centuries have figured it
Okay,
out. The same
I'll
old
address
shit
it
you
again,
always
Brandon.
spew out of your
Since you
mouth.
missed it, I'm quite happy to address it again. Obviously, it's not true, because if it was, we would see Polaris apparently move with respect to other stars in the sky. Likewise, if it were true, and if stars were close, as he is claiming,
why do you say
we
that?
would only be able to record circular star trails.
The only way it would move is if you're moving, pal.
Why?
We would only be able to see circular star trails at the North Pole with a camera pointing straight up. As we move south,
You're lying right through your teeth, bro. There's no refraction at the North Pole. I've said that 10 times.
As we move south, we'd get a narrower and narrower.
If you're moving, Polaris
as we
is
move
moving on
south,
either model.
it's
if you're
amazing
moving,
how he
Jim.
needs to block me out, isn't it? As we move south, it would become more and more elliptical. Simple. It cannot be true.
It cannot be true. That pretty much sums up your entire argument, doesn't it, Jim?
Well, if you choose to ignore everything I said before that, yes, but that's because you're
pretty much all
intellectually
you said
dishonest
was, it
and you're
cannot be
desperate to pretend
true.
that this bullshit
That's all
might
you
have
said.
some use to you.
It cannot be
doesn't.
true.
It's bullshit.
It
Reality
cannot be
tells
true.
you it's
it has
bullshit.
to be this way. You haven't given us anything of substance.
Well, okay. You respond to what I said. You haven't responded in any way.
You're just spitting out rhetoric.
Explain to me. Explain to me. Go ahead, Brandon. Explain to me how, if the stars are close,
proposed, the one that
if
you're
the
saying
stars
is
are close,
impossible.
if the stars are close, how are we able to get circular star trails by pointing a camera to the North Star anywhere on Earth?
Why wouldn't we get circular star trails?
You rebut what I'm saying, Brandon, instead of just saying you hadn't said anything of any substance.
You haven't.
When you've ignored everything I said twice.
No, I didn't.
You get arc
Fuck you,
once
lot.
you're to 45
You're delusional.
degrees and further.
You're delusional, dude.
And there's no refraction under the North Pole. I done told you that. You're straw manning me or you're lying. One or the other. You don't get circulars overhead. You get arcs off of the fucking distance. Fucking idiot, man.
Anyway, it is 8 o'clock. That was a nice end. Thanks for stopping in, Joe. Appreciate that. Why don't we do final thoughts? We haven't done it for a while. We'll start off at the top with Allie B, unless he's asleep. He's asleep. Andy.
I literally just got here. Sorry.
Oh, no problem. All right. Angel of Attack.
Just got here, but sounds like a crazy show tonight.
It was interesting. Autodidactic. Biodual. Okay. Brian Leakey. C4. Bueller. Chad.
Great show.
Thank you, Chad. Thank you, buddy.
All right, thanks.
Thank you, sir. Chikey. Okay.
Hey, Brandon, what's up?
Oh, whoa. What are you doing out of your walled garden?
How you doing, my friend?
I'm doing just fine. How are you?
Man, I'm great, man.
Nice to see you around. What can we help you with?
I just got a few moments, actually, man. I want to discuss the ISS with you for a couple minutes.
Sure.
Okay. What's going on with it? How high is it?
I don't know.
Is it an actual satellite?
Depends on your definition of satellite, but it sure looks like something that is up in the sky and travels around the Earth, meaning in a circle above the Earth.
Okay. I don't have a definition of a satellite, but what a satellite is actually artificial. It's actually an artificial satellite put up by men.
Yeah.
It has solar panels. You can see it, right?
I would agree.
Okay. And it's been measured by amateur astronomers to be 250 miles high and going at the speed of 17,500 miles an hour.
Well, I don't know about measured. I guess that'd have to do with your definition of measured, but okay. It's 250 miles up and it's going 17,000 miles an hour. Anything else?
Yeah, that is an orbit around a spherical planet.
Ah, there it is. It's going around a giant ball, spinning and floating through endless nothingness. I gotcha. Yeah, I knew there was a catch somewhere in there.
Exactly. Just like we can look at Jupiter and see their natural satellites, which are moons, going around them and what looks to be like nothing. So that's evidence right there in itself that we do have at least one satellite.
Well, we have things up in the sky that go around. They don't necessarily go around us as a sphere, but yes, we see things up in the sky. Yeah.
Do you have evidence of that?
Do I have evidence of what?
That is not going around. That is not in orbit of a sphere.
No. Do you have evidence
we have
that
evidence that it's in orbit.
Welcome to Flat Earth.
No.
Just because you can see it up there in the sky doesn't mean it's going around a ball.
Not only
You
can
thought
we
it
see
went
it,
around the ball, didn't you?
Not only, hold on, I was talking to Brandon. Not only can we see it, but it's predicted every time when it's going to come around using the globe model on what is the app.
Using the globe model, you use any model you want. You know what time it's going to be by. It does the same pattern, right?
Do you have a flat Earth model that can predict it?
I can predict when that thing's going to go over. Yeah, I don't need your ball model to predict when that thing's going to go over.
It predicted eclipses.
Okay, well, how do you predict
the flat Earth model?
Exactly.
Can I ask anyone where's the citation that says that if you predict something, it concludes to be true?
Yeah.
It's in Houdini. It's in Houdini's second book.
To predict. Models are. I can look at my clock.
He did just say that.
And it's at 1, and I can predict in 2 hours it's going to be in 3 o'clock. What does that mean?
I'd like to make a quick point, man. A quick point. If Polaris was like,
hold on a minute. I'm gonna wait for this guy to come over for a while. Go ahead.
This is all right, but I got something very important after you.
Okay.
Yeah. So Brandon, using the globe model, we can predict when it's gonna come using the app that is called ISSTransitFinder.com. And you can ask your boy SE Montreal because he said out his own mouth verbatim that he used the globe model to track it. So, is there a flat Earth model that can explain the International Space Station?
Yeah, my refraction model does. Let me say something real quick, Matrix. This is so important, y'all. This is so important.
Let Brandon.
Hold on. This is very, very important. This is my final thought. Okay, so if I'm standing right below Polaris, it's if it's light years above me, and all the other ones are circling around it because I'm spinning. Okay, if I tilted myself 45 degrees. I would just be looking at a little bit of a different angle, but it would still be spinning straight over my head, basically. So what's the difference if it's that many light years away? What's the difference in me moving 4,000 or 5,000 miles to the right? If it's that many light years away, why would I see arc on the horizon? It's got to be refraction. It can't be us spinning, y'all.
Okay, Brandon. Okay, Brian. But I was trying to discuss this with Brandon real quick because I don't have a lot of time.
Yeah, so your point is we see ISS and we can do mathematics and know when the ISS is going to go pass over us and where it's going to pass over. Therefore, we live on a giant spinning ball. Is that it?
Yeah, well, the International Space Station is absolute proof that the Earth is a sphere and that we have satellites orbiting the Earth.
No,
it's absolute proof.
No, it's not.
It can't be a sphere, bro. It can't.
Brian,
It's just not.
Right.
So you're using the thing in question to prove the thing in question?
Hold
Yeah,
on.
he is.
So
hold on. Do you have any pictures of a video of satellites not going into clouds?
I don't even know what that means. But Brandon, we was discussing the International Space Station. That's one satellite. I don't want to talk about the other ones that you guys can hand wave dismiss. I'm talking about the one that we can all
I
do
didn't hand wave dismiss anything. I said, okay,
I didn't say you.
There's an ISS up there. I even gave you, okay, so that's 250 miles up. All right, it's going 17,000 miles an hour. We see it go overhead. Okay, we can predict when it comes by. And then from there, you jump to, that means we're on a giant spinning sphere.
It absolutely means it, because 250 miles up, that means it's in space. Hence the name of it, International Space Station. 250 miles up is in space. It's going 17
that's
and a
okay.
half.
250 miles up on the flat Earth is in space there. So that's gone.
Okay. All right. Now,
so
great.
What's your point now?
Now my other point is, what's keeping it up there?
Well, good question. I would assume that is military technology and probably secret information. So I really can't say.
Well, it's
You
not
can keep a
military
plane in the damn
technology.
sky
It's
for a
not-
I mean,
it's
we
not
know there's
military
lots of ways to keep something up in the air, right?
It's not military. It's not military technology. It's simple physics.
Yeah, that's what you say.
It's simple physics.
Yeah, that's what you say.
Yeah.
You can keep an airplane
it's
in
in
the
free
sky
fall. It's
for
in
a
free
month.
fall around the Earth, which is called an orbit, and it's on a tangent.
I've heard of that. That's where you guys think that things are continuously falling towards something, but never hitting it, and they just stay the same distance and go around and around.
Because it has a tangent velocity, and it's constantly missing the Earth. That's why it stays in orbit.
That's
the closest to a perpetual motion machine you'll ever find. I mean,
listen, I'll concede the ISS, man.
Prove it.
And the speed that it's
I'll
traveling.
concede the ISS just to kill your model, dude. Yeah, and I ask you one question: if you're standing directly under Polaris,
I'm not talking about Polaris, Brian. I'm about to get off the line. You can talk about that when I get off the line. I'm not talking about Polaris.
Yeah, but you can't be on a sphere. It's not even possible. If you lean 45 degrees from under Polaris, that's the same as going to 45 degrees latitude,
Brian,
right?
Okay.
You're just a few thousand miles off to the side, right?
Okay, Brian,
how much?
Okay, Brian, that's fine. That's fine. Brandon, you just said that it's if it's 250 miles up, then that means that it's in space over a flat Earth.
Sure.
So now I'm asking you, but you answered the question. You said you don't know what keeps it up there, but we do know what keeps it up there. It's simple physics.
How do you know? How do you know what keeps it
Of course,
up there?
you know how they know, Brandon? Because they made it up themselves.
But it's there though. It's there.
Yeah. And you say it's a satellite, and I say it's a white chocolate white chocolate candy bar.
Prove
me
know
wrong.
It's not a white chocolate anything.
Prove me wrong then. Prove me wrong.
Because we can
show me the evidence.
We can hold on. We know it's not white chocolate bar or whatever you said. We can see it. It has solar panels.
But what you're doing is the equivalent of me using the Spider-Man comic to use Spider-Man, right? I'm using the source material. I'm literally using you're using the source material, the thing in question, to prove the thing that in question, bro. You don't get the fallaciousness of what you're saying. You could assert it all you want, but it's the thing in question.
I don't know what you. Do you have a mouthpiece in your mouth or something? I don't understand what you're saying. But
hey, check it out.
Yeah,
Look,
I got my tongue in my mouth.
Okay.
Hey, Brandon.
Yeah.
If I'm under Polaris and I do a small circle, I just spin a circle like I'm doing a little mini Earth. My feet stay in one place. Polaris is gonna stay right over my head, right? Because it's so many light years away, right? Okay,
Brian,
so I do a mini circle like I'm rotating around the Earth. When I get to 45 degrees, Polaris is still overhead. Okay, so if I'm just go a few thousand extra miles, it shouldn't be 45 degrees on the horizon.
Brian,
it should still be over my head, dude.
Brian, you're forgetting about the Southern Celestial Pole. Come on, man, just give it up.
Brandon, did you see Brandon?
All right, man. I don't think y'all understand how important that is, though, man.
No, we don't, because you're still forgetting about it.
You think that just because I tilted 45 degrees to the side, that Polaris should drop down to 45 degrees on my horizon? It's got to be refraction. It can't be
no, it's not
the Earth spinning. It's not even possible, dude.
Brian.
Yeah, Brandon, but that's why I didn't want to come in, because I knew that you and they don't have any
I'll back
respect.
off, y'all.
They don't
Sorry,
have
man.
they don't have
want to
any
get that
respect
across. I'll
for
back
you.
off.
They don't have any respect for this. They don't have
So
any
before
respect
they
for you
even
and
had
your
the
show, man.
ISS, before they even landed on the moon,
Well, I'm gonna
in
close the show out.
1929,
Yeah.
Come back
In
when you got some
1929,
actual
Brandon,
evidence, though.
to
I
you,
mean,
King.
you just kind of came in here and says Earth's a sphere. That's all. That's all you really
No,
said.
that's not. No, that's
It
not
is.
what I
It
said.
is though. You didn't offer any actual
So
evidence.
when we can't, when
Hold
we
on,
can't
hold on, Brandon. You said I didn't
I make
offer
shit
any
up.
No, you didn't. You would. I didn't say that you didn't offer any facts.
Brandon,
I
you
gave
said
you
I didn't
some
offer.
facts. I'm talking
Brandon,
about
you
the
said I
shape
didn't
of the
offer.
Earth. We're
You
not
said I
talking
didn't.
about whether there's an ISS up in the sky. We're not talking about how
What I'm
fast
telling
it's
you, what I'm
going.
telling you is this.
You're just telling me your theory of how this thing is perpetually falling
No,
over the Earth.
no, Brandon, it is not. Brandon,
And
it
that
is
you
not
see
my
it up
theory.
there and you can time it. And
Brandon,
that
it's not
means
my
that,
theory. It's there. It's there for all of us to see. If you can't explain it on a flat Earth, but we explain it on the globe model, then what do you have?
So if you have a story and I don't have a story, then you win. Is that what it is?
No, it's not a story, Brandon.
Pretty
It's
much
there.
in
We
a
can
court of law, yeah, that's kind of how it works.
Look at these guys. Look at these guys.
In a court of law, that's kind of how it works.
Brandon, it's not a story. We can see it. We can measure it.
I'm
Because we
asking you
can
for
see
some
it and
scientific
measure it.
evidence.
That
dude.
automatically means that it's whatever the authority claims
No.
it is, right? That's logical to
Like,
you.
prove to me that there's
And we
this
got pictures
thing
of it
that's
up close.
falling continuously around the Earth and never hitting it. Prove that. It makes much more
Yeah,
sense to
all
me.
we gotta do is apply. All we
than
gotta
it's
do is
just
apply our
surprise.
math to it,
God
dude.
damn,
We
man.
apply math to it. It's proven now.
Brandon, here's the proof. Go to ISSTransitFinder.com. Get a friend. Do a transit of the moon. When you do that, do the math or learn the math that it takes to measure the speed and the altitude. And there you
That
have
doesn't prove that it's a sphere.
Dude, in our model, the moon is only 3,500 miles high, bro.
Somebody.
Yes, we get different numbers than you, bro. Our model, our moon is only 3,500 miles high.
All right,
It's been
There we
fun.
go. The moon.
Okay, holy shit. Thank you guys very much for listening tonight. I really appreciate it. Thanks for supporting the show. We'll be back tomorrow. Yeah, I would have liked to have a conversation with him, but maybe he's right. Maybe it is impossible in here. But anyway, we'll see you guys later. I don't feel too bad about it. Have a good one. Thanks again.